Here is the Codecademy catalog. Should I pick one already? And I'm going to do C. I'm going to do the basic C, and it's beginner friendly. The level, it's very low level. It introduces you, shows you what are variables and conditionals and loops, arrays and strings like every normal language, and then also teaches you about pointers and memory, which is something the others do not use. They automatically point, but on C you can choose the exact pointers and can make it more efficient. Let us go. You open like this and you enroll. Anything else? Oh, wow. The C programming language makes the very basic system that the bots use. It makes other programming languages, the operating systems, and everything. Congratulations on choosing to learn the C programming language. C has been around for quite some time, and it is one of the foundational languages of computer science. C is an older language compared to other languages in use, and yet it is still very popular. The TIOB index, which measures the popularity of programming language, has C at the top of the list for many years. This is due to C's use in all areas of computing. Most operating systems today, including the Linux kernel, and implemented with C code, are implemented with C code. The main version of the Python programming language is named CPython because it is implemented using C. C has also been extended using the language C++ and C Sharp. C Sharp is the godly language nowadays. C is also common in embedded systems, which are smaller computing units that control things like home appliances, lighting controllers, and other small physical devices. The C programming language is everywhere. Learning it will help you become a better programmer, ready for the next challenge in any field of computer science. The embedded systems are those small computers that work on a single job as a home appliance. The workspace shows the C programming language reach throughout the computer landscape. Through the code in operating system, other programming languages are embedded system. In embedded system, C is everywhere. Next, hello world. So let's look at our first program. You include this. When this code is run, the following text is displayed in the terminal. Hello world. Let's go through the code line by line to see what is happening. You don't need to understand everything right away. It is just a look. Include this. This line is needed to run the line of code that starts with printf. So printf is a function, and this function is contained on this. Int main, this is the starting point of the code. All code inside the curly braces runs first. So you cannot just throw your code here and it will run. You have to import the basic functions that you want, and then you run whatever is in main. When you're making a game, you just call the main game loop from here. The first thing is open and you call the other functions and things from here. Output a line. This is a command. It is not a line of code, but a message we can add to code to tell themselves or other what the code does. When the code is run, this line will be ignored. Printf. Hello. This line of code prints or outputs the text hello world to the console. Printing text to the console is one way for a program to communicate with the user. Try running the code and see the output yourself. Right. Hello world. They can write comments like that. They have no effect. can print anything. This is a new line. So if I put dig here, it will be a new line. If I take it out, it will be the same line. Syntax and errors. When writing C, we need to follow a set of rules in order for the code to run properly. These rules are known as syntax. As we go through each lesson, we will learn new syntax on the topics being covered. Let's look at the Hello World code to examine common syntax that will exist in most, if not all, of your programs. Case sensitivity. Most of the words in the code use all lowercase letters. This is known as case sensitivity, whether console or uppercase. Certain words in the code must follow the correct case in order for the code to run. The only lines of text that can change case are the comments and the text between quotes. All statements, like printf statements, need to end with a semicolon. This identifies the end of the statement and is needed for the code to run correctly. Double quotes. The text in between the double quotes is known as a string. Think of a string of characters. All strings must be surrounded by double quotes. So what happens when we break the rule? The answer is errors. The below text is an error that is output when we leave off the semicolon from the print statement in our hello world code. Expected this. The text above gives the following information: the component location, the line and column number, and the description. As we can see, the message does its best to help us solve the errors in our code. Run to see the error. Line 6 1. It's expected this before that. Oh shit, I erased it. What error will it give? It's not very helpful. Description. Oh motherfucking hell. Dang. Some white needs to be on the same line. Which, but okay. It's crashed. Not running. Given the error in the console, can you fix the script? It is still an error in the console. Give me this new error. Can you fix the code? Oh, it's the main. It's not being case sensitive now. If I put it down here, raise it up here, it runs like normal. But it marks the end of the statement anyway. If I put the F here, it will not run. That function does not exist in this included. You need to be exactly at the function you are calling. How do you declare a new function? There's something wrong. How do I pass a variable here? It's not as C#. I'll have to learn it. One type of DD defaults to int. Why does it default to int? I cannot put it as a string and it defaults to int. Crazy shit. We will learn it later how to declare a function there. Output. The main goal of a real world code example is to output the text hello world to the console. A line of code outputs the text is a printf hello world. Let's dive deeper into the second part of this line into the two parts of this line Printf is known as a function and performs the action of printing text to the console. Hello world is a string. A string is text in between a pair of double quotes. Placing the string in between the parentheses of the printf function prints the text with other quotes to the console. Functions and strings are topics covered in later lessons. Don't worry if you don't understand the concepts fully. The important thing to note is that this is how we create output in the console. What about the /n at the end of the string? Good question. This is called an escape sequence and is used to add a non-visual character with a string. In this case, /n adds a new line to the end of the string. Look what happens when we place it in between hello and hello. Yep. It is important to remember an escape sequence is a character and must be within the double quotes. Another escape sequence is /t. This is equivalent to the tab key and it will insert spaces within a string. The code above will output /n and /t are just two of many different escape sequences that can be put inside a string. The code in the workshop outputs some text to the console. This is supposed to be an easy to follow recipe, but when you run the code you see it's not that easy to read. Run the code to move on and fix the recipe. It's all on the same line because I'm telling it to output this thing, I'm telling it to output this thing. It's outputting it all in sequence. I have to inform the code that it needs new lines. And to do that, on the first statement inside main, add a new line escape sequence to the end of the string. So I have to put this thing and then end, which is make a new line. Does that. This slash thing, I do not have it on my keyboard. So if you use Alt +92, you'll get it if you need it. This other one that is used on comments, you can get on your number pad. The next statement needs a bit of space in the middle. Within the second printf statement, add a tab escape sequence in between the words butter and run temperature. Something happened. It's t/t between a tab escape sequence. In function main is script 7. Yeah. Oh, wait, shit. Not the command cannot take the escape sequence. It ignores things and does some special function. So it broke the comment sequence. This recipe needs to be sweeter. Within main, add a printf statement that outputs the string. Notice the /n at the front of the string to ensure it is output on a new line. This is very weird. It's telling me that it should output this. I need to escape the escape sequence to output this. But what they mean is that I should write exactly this to output this rest. So like this, print f, I call the function and I make the string. If I wanted to output that, I need to escape the escape. Put it like this. Cups granulated sugar. and then I close it with a semicolon. As you can see, I wrote exactly that. It outputs what I wanted. Like this makes the thing in front of it be ignored. So if I leave it like this, the n is ignore has a letter and functions on the code as the n special character. But if I put 2, the thing in front of it, so this slash is ignored. So it's no longer ignoring the n. So both are written. But what it meant it was that it should appear like this. Although that's not what they are saying. Comments. When we write code, it is important to document the code's behavior. One way to do this is to add comments to our code. Starting a line with a double forward slash, we'll create a comment and the entire line will be ignored when we run the code. Unless you have some escape on that, but yeah, usually it's ignored. That's not a fact. The comments, like the ones above, can be added about a line or a block of code. Describe the code's behavior. Shorter comments can be added to the end of a line of code as well. In both examples, once you use the double slash, the rest of the line is now a comment. If you want to create a comment with a beginning and end, you can use the slash asterisk to begin the comment and asterisk slash to end the comment. This is known as a block comment, like this. You can see on the above example a block comment can wrap multiple lines without the use of anything but the beginning notation, the ending notation. The code in script C is outputting a couple lines of text. Make sure you annotate your thoughts above each string. The output. Above the first string statement email, add a single line comment with your own message about the string that's output. So on the first, you comment on it. Chocolate is good. Chocolate are better than oatmeal raisin cookies. Chocolate does not appear, it's just a comment to whoever sees the code. No effect on the output. Now give yourself some more room for commenting your code. Above the second statement is add a block comment with your extended thoughts or the string. While your addition to the code do not change the output, you have now recorded your thoughts on the code, which might come in handy when you revisit the code another time. Learning the C programming language is an exciting adventure. This is a comment of many lines. As you can see, everything to the end of the code is commented out, so it will crash everything unless you close it. It's color coded to make life much easier when coding. Compile. At this point, we have run our code within Codecademy's learning environment. While this is how most of the exercises will go, it is important to learn about running your code using a compiler. The compiler is the program that converts your code to an executable program that can be run on your computer. This involves reading the code from a file and compiling it into code the computer processor can run. A widely used C compiler is GCC, which stands for GNU Compiler Collection. Let's look at how we can compile hello world.c to hello world executable. Hello world C includes that thing and it prints hello world. To compile this code, we need to run the following command in a terminal. Get to that file The above command can be broken up into two pieces. GCC is how we run the compiler application, GCC mode. Hello world.c is the file name of our code to be compiled, of file. O, hello world, is an optional but common addition to the command. It tells GCC to output the program executable under the name hello world. If this is left out, the executable file will be called a.out. After running the command, we have an executable. How do we run our code? We can run the executable with the following command, again using the terminal. Open that file, in this case hello world. This command tells the computer to look in the current directory and run hello world. Move on to try this out for yourself. The workspace has changed. There is now a bash terminal you can type into. Using the terminal, manually compile the hello world code in script-c. Run gcc on the script.c. Name it hello world. Run the script again, and I can name it Mike. Oh, fix it up. I can run it again. If I look at the directory, there's the again hello world Mike in the script-c. There are these 4 files. As you can see, when I run D before, there was on the hello world and the script. I have several files, and I can tell it to run any of them. Oh, Mike. What? And this directory gets to Mike. Mike itself should work, but I need to specify the directory this time. I have no, do not use space. There. Run Mike here. It does that. The thing did not accept that. It wants me to run exactly the hello world. It is checking what I input, not the actual output. It's the same thing because it just compiled the same script on a different name. And if I run again, it will output the same hello world thing. If I change that thing now, let's say hello guy. Shit. If I compile it, it's the gcc script.c, name it as get. Now if I go at the directory, I can run again. I can run gap, will output the new script. And if I run again, it will put that, it will output the hello world thing. But now I have saved the code in different forms, in different executables. I can run enough them by running the any executable that I have on the directory. Summary. Great work getting through these 5 exercises. Let's review what was covered. C has been around for a while, but it is still very popular. Code syntax is a set of rules that are followed when writing code so the program is able to compile. Errors occur when the syntax is incorrect. Error messages make a best effort to describe the error and where it occurred. Use printf to output text to the console. Comments are used to include text in the code that the compiler will ignore. Line comments start with // and block comments are surrounded by /***. The GCC application of the new compiler collection is a compiler used to compile C programs. You also use it for the sons of C. There's something here. I learned for fun. Like some quiz if you get pro, but will just be doing the normal ones. There is some text here. Formationals. Bring C to local computer, explore the power of C programming language with a local programming environment. While it is nice and easy to write code on the Codecademy platform, you may eventually want to work with the C programming language on your local computer. The best way to do this is with an integrated development environment, commonly referred to as an IDE. IDE are used for applications that assist programmers with many tasks as making the fucking program. Instead of making that thing here on the internet, I can come here and download the C IDE. And you download and that you feel like using. So you just disappear. Yeah, but my desktop not appearing. Here is my desktop, and if you come download the Visual Studio Code, you can come here and look for the C program things. So you get it and you'll be able to write your code. You can write it anywhere, really. You can write it on a block text. That what was it called? Was there anything on the main? Printf hello world. Close it. I have to import. I forgot the name of that thing. But if you copy that code, if you write it like this, you can save it like a .c program. And in order to compile it, you need to have the tools on your computer. But it will work basically the same way. You save them naturally on a folder. You have that several executables as you compile them. There are many IDEs to choose from. It's good to use one that is free and supports a wide variety of programming languages. VS Code, that's what I just mentioned, is an open source IDE created and maintained by Microsoft, and it's an excellent choice for C programming. Install VS Code, just go there and install it. Install C extension and compile. That's those extensions that I mentioned. You have naturally the Microsoft terminal that you accept those commands to compile it. After installation, you need to add C support and the proper compiler for your operating system. This is explained using the VSCC docs. Once completed, you should be able to compile and run a C script within the VS command line. Explore VS Code. What is a variable in C? In this lesson, you will learn the rules for naming variables in C, the main data types in C, int, float, double, and char, declaring and initializing data types in C, as well as changing their value, casting from one data type to another, and potential limitations in C. Let's start with what a variable is. It is a reference used to store information for future use. For instance, int score can be called later in your code to assign, change, compare, etc. In this example, you can see the basic structure of variable creation, known as declaration. Is type variable name. Type variable name. Have no fear, we will go over each part of these and more in this lesson. Specifically, we will cover how to create, name, assign, modify, and convert them to different types. As a bonus tip, right from the start you can create more than one variable of the same type. at a time by listing them with commas between the names, like type, variable, 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 variable. That's very confusing, not you that be a normal person. And list them separate like this. We are going to start with the second part of our variable declaration. Type variable name. The variable name C does not allow you to throw anything down and call it a variable. There are some restrictions. Name can be composed of upper and lower case letters, numbers, and underscore. The first character must be a letter, upper or lower case. No keywords are allowed, as the full name int is not allowed, but int count could work. That's it, nothing too crazy. Just keep those rules in mind when you are creating your name for your variables. The code on the right has errors in each of the variable declarations. Look at the rules for variable names above and fix each of them so that there is one variable declaration per line and the code compiles. When complete, you will see below what the output window. So it crashes. There is some information. The first is on 5 somewhere. Expected equal on the attribute before the node token int number. It is weird, but if you look at the rules, what they mean is that this is not a character that can be put. You cannot put that. You put letters, number. You cannot put spaces either. X12 expect an equal. This output is not helping because they are asking you to put it like this. Declare the variable with a value. They are all empty currently. A space is not allowed, so you need to put an underscore if you want to. EA is no, it's an 1A. It's not allowable because it needs to start with a letter. Now it should all run. Float int, it's not allowed either. Hello, there. This one had one character, it could not. This one was separated, cannot be. This one started with a number, and this one was using int. That is a key to add something or take something out of it. Data types. What about that first part of our example? Type. Type variable. We saw some examples in the previous exercise when you corrected the bad variable's name, but let's talk about what they are. The type of a variable denotes what kind of information can be stored in it. C has a good number of types you can use, but in this lesson we will go over some of the most common ones: int, float, double, and char. In C, you must specify the type of the variable when you declare it. Once it is set, that type of information is the only type that can go into that variable. So if you create a variable of type int, which can only store whole numbers, you will not be able to store a, not 1.2 in it. The table below details these types. The table below details these types we are going over and what information can go into each. Int are integrals, integers, whole numbers. Float is a number with decimals, and double is a number with more decimals. Why is that distinction? Because they cost a different amount of byte to run. A character is a simple character. when you play games, when you do things, you will see that they have a limit. For example, how much gold can you have on Elder Scrolls Arena, which is a game from DOS? You can only have 2 billion because that is the character being used there. And that's the same maximum experience you can have too. And that's a very common number to have in games because the variable they choose to use. If you use heavier variables, it will take a little longer to run. It's pretty meaningless today with the power of machinery you have. But if you want to optimize your code, that's the thing. They do not make really difference nowadays. But if you are competing for microseconds, you have to use that information and the right types. There are a few questions you might be asking yourself looking at these descriptions. What's the difference between float and double? Oh, sorry about that. We're going to look at this in the next exercise. Character holds a single letter or number. Number is also a character. But what if you want to store something like a person's name that is more than one character in most cases? That gets a bit more technical, and you will learn about how that works in the lesson on strings later in the course. The code in the editor is ready to display basic information about an imaginary student. The problem is the programmer forgot to declare the data types for each variable at the top of the program, so it will fail with errors. Go in and add appropriate data types to each variable, so when you run the application, the program completes and student information is displayed. So I include that thing I call an int. What the fuck is this an int, man? It returns an int, which was okay. On the main, I have to fix the data type. There is the student rank, there is the student free total, and the student grade ladder. So I have 3 variables here being declared, but they are wrong. They need a type. They are valid declaration. No need to make any changes below here. Use these as a hint to how each variable above should be declared. The rank. So this will be an integral number. This cannot be, they cannot rank 1.5. They are either rank first or the second. This is an integer, an integral. Student fee total. So how much do they owe? Let's just mess with this. So this has some cents to it, 100 and some cents. This might not be an integer, it can be a piece of a number. So we call it a float. And the student grade ladder. So this is a character, a letter. Character. Now it will print it. It has some new syntax here, but yeah, you print it. What did you see? Print function. We are going to take a little detour for a minute to help you understand what is going on in the code in the lessons. You might have noticed printf at the bottom of some exercise. This allows for text output to the terminal. The basic format is printf, string to display, and some list of optimal parameters. So if you had something like printf hello world, the terminal would display hello world. When was this lesson written? Before they had the hello world lesson. They decided to put the hello world lesson in the middle of the variables lesson. Pretty weird, but here we go. The optional parameters let you add values dynamically into the string, such as values stored in the variables we have been learning about. For example, if we wanted to output hello world, today is the 3rd, you could do that like this. Hello world, today is the when the compiler runs the code, it will replace the percentage d with the value, the variable list, taking them in the order found in the string, found in the string matching the order they are listed. First is the string is matched with first, the list of parameters. First in the string is matched first. There is an article missing here. The first in the string is matched with the first in the list of parameters. There are lots of optional formatting and parameter types that can be used, but for our purpose here are a few of the basic ones. For our purpose, here are a few of the basic ones. There's a comma missing here. To indicate a variable type, you want to replace d or y with integer, f with double float, and c with character. You can also use some reserved symbols within the string to have invoked format. Here are a few common ones. That new line we saw, the tab we saw, and there is a carriage return here. They are not using. Carriage return. That's correct. Add new line command at the end of the first printf so that the output is clearer. As you can see, this will print all in one line. You have to separate it. The print statement has been fucked up. If it was printing a new line, it would not do that. But yeah, it's separated now. Modify the printf command in the code to add the variable to the output so that the output makes sense. I was years old, so I need a number here. How old I was. You can put any shit you like your fucking queue here. And then you list age learned to write. Crash it. 8 years old. Unknown conversation type of character. It actually needs to be an I. Okay then. So you need to put this actual symbol, indicate the variable type it's matching. You cannot just put anything in here. If we go back to lessons on this one, where there is some very weird things, we can see they do it like that. We call a variable, input a student grade letter, and here we call a number in student fee. And here they call a d followed by an s. If we have two variables like this is a student loan and this is some random number I want to put. Let's put a list here and let's put the student here a rank with it. Now n and 1. So it's displaying this and this. This is mapping to the first variable and this is mapped to the second variable. Like they mentioned that. Initialization. Let's get back to understanding variables in C. Now that we have our variables, we know its name and what it can hold. What do we do with it? Right now it's empty and doesn't serve any real purpose. A variable's power comes from its ability to be set, changed, and examined. So the question is, how do we do that? There are two ways to set a value. For now, let's look at how to set the value when you create the variable itself. Int example equals 3. In this case, not only have you created the variable, named it example3, and identified it to hold whole numbers, the integer, you have set its value to be 3. We have saved time by doing all these parts in one line. When declaring a character, you need single quotes around it. Google. The code has several variables, names and types already set up correctly. First, set an appropriate value for number of books variable. Notice that the code does compile without the other variables set to specific values, but gets some strange results. This is a good lesson to keep in mind. The compiler will run your code if you don't set a value in most cases, unless it's required for something. But you won't be able to depend on the value in the variable. It is good practice to set a default value for variables you create as soon as it's practical in your code. So if you try to run the set, not doing shit. Okay, I have to put things. They did not allow me to see the empty error message. Number of books is an integer. So this is a number, a whole number. You can separate like they show here. We right here, but it's unnecessary. Character. Favorite letter. What if I put a Greek character? You accept it? Let us see. Favorite digit. It's supposed to be a number? The number is still a character. I like this number. It does not accept the Greek thing as accepts this one. Yeah, these things are actually different, this one from this one. This is the Greek version, which they do not take. A double. This is a number also. And it can have piece of thing, floating point. Okay, they show here with an F. Dot something. And it crashed. Warning. Multi-character character constant. Favorite letter beta. They do not accept the beta, that's a composite character. It has to be a simple character. Watch? Oh, my digits thing. They do not accept that either, it's composite. What's your favorite letter? Oh, it's asking to put it now. What's your favorite digit? What does it cost? Yeah, everything is it. Right type of thing. They go each lesson asking for the answer of each. Float and double, what's the difference? So why are there two different types of decimal in C? The short answer is different types for different situations. A float has less precision than a double, 6 versus 15 possible decimals places respectively, and therefore takes up less memory, 4 versus 8 bytes. However, a double runs faster, so you gain speed at cost of memory usage. The other thing to be aware of is that the system is rounding the values you store in either. This can cause unexpected results, especially with a float as they have less precision. This is why you will see double being used anytime accuracy is important, such as in scientific, medical, or financial applications. In this example, much of the code is already in place. Don't worry at this point if you can't follow everything that is going on yet. You will learn about loops in a later lesson. For now, you want to experiment with number of loops and keep increasing its value until something unusual happens with the output, especially the float value. In general, the program takes a double and a float and adds 0.1 to each over and over again number of loop times. So if you set to 10, that means it's adding 0.1 10 times or 0.1 times 10, so the output would be 1. Float and double both give you this value, but keeping making number of loops higher, and the float will start to give unexpected results, showing the lower precision rounding issues. Why is that the case? It's really weird. Oh, but it's rolling. Updating values. Before, we say that there are two times when you can set a variable's value. We just examined how to set it at declaration. But if that's the only place it could be set, variables would have limited value. We will see in a moment an exception to this rule. It turns out they can also be set at any future point in the code. As an example, int total units, so I declare it. Now there exists something called total units, and it's the type of int, and later I can put that to means 3. Notice that once we have declared the type, we no longer reference the type, just call that thing that already exists. Here we say it exists, and here we say that the thing that exists and is called this has a value of 3. We just use the name of the variable. You can also set a variable to be the same as what is stored in another variable, such as a equals b. If you change b after this, the value will no longer match. That is a way to tie the two variables together so they always match, but we will get to that in a later lesson. You put on the same point, or then to point to the same thing. Have no fear, we will go over how to do more advanced things with setting the values stored in a variable short. In the program on the right, someone has created the initial code by declaring and setting up information on a book turned movie. The output has also been taken care of. What you need to do is update the values based on changing information from the market. The initial movie review were generous, but have gone down since opening week. The average score for the movie is now C. Please update the score. For main, these variables were created and had a starting value for you. No need to change. Update the movie review scores here. So the score changed. Average score, movie price, movie version review. So the movie version review is a carga and has fallen down to C. I close the statement and I give a tab in order to organize things. This has no tab, this has a single tab, and anything that be inside of something here have due to dropping movie ticket sales, the movie theaters decide to match the price of the book to make up for the lost revenue. Set the price of the movie ticket equal to the price of the book. So the ticket price has to equal the book price, whatever it is. So I could hard code this and put the ticket price to be 19.99. But then if someone changed it, the book price, this would still be 19.99. Now if anyone changed the book price here, the ticket will automatically follow it. Constants. In most cases, variable values can be changed in the program. However, there are cases where you do not want to allow for your variables to change value. This is where constants come into play, which is something quite not used on most languages. It's kind of silly. But yeah, here we go. These special types prevent any changes during execution once the value is set at declaration. Any basic data type in C, like those we have gone over, can be declared as a constant using the keyword const before the type. So instead of our template of type variable name, it would be const type variable name. It is also a best practice to use all uppercase letters when declare a constant. Like this. Days in week. You do not want this to change. Or you do want that to change again. But yeah, if I writing a program for a bank, you do not want days in week to be something that people can change. The speed of light is a constant, so a great candidate for an example of the constant variable type. For the first step, identify the speed of light as a constant. Notice that the name is already fully capitalized to match constant best practice. They make me write that the speed of light is constant. The shame. The shame. The constancy of the speed of the light. So it's constant. No, that's wrong. This is where the value is set. It's wrong, but fuck it. You have to put it on the declaration. You cannot turn it to a constant later on. It has to be made a constant at birth when it's declared the first time. The program now violates the rules of constants. We know the speed of light won't change, so how can you fix the code to run correctly by obeying the rules of constants? So this is unchangeable. Thus, I need to set it at declaration and erase this. Now it works. And as you can see, something very silly is being done, because the print says light would travel this variable miles, this variable seconds. What happens is that the first variable is not speed of light. They have an entire equation. They are multiplying the speed of light by 1,000,000, 100,000, and multiplying that by the time traveled in seconds. So this thing here displays not only the speed of light, but the result of this entire equation. Miles in seconds is just this variable now. Time travel in seconds. But as you can see, you can call the variable here and make an entire equation that will take the place of this first variable. Casting types. Sometimes it's useful or even necessary to change the value type of a variable and use it for other purposes. For instance, if you had a double with a percent score on a text, say 0.95, you would most likely want to display 95% to the user instead. Notice we are not changing the type of the variable, not the value stored in the source variable. What we are doing is display the changed variable as a new type or storing it in a different variable that might be a different type. So you could not do this. Int a double b a equals b. There are two types of conversion, implicit and explicit. When you set one variable to be the same as another, such as a equals b above, but the types do not match, the compiler will try to convert them. However, this can be dangerous, as you might not know what value should be in the variables at runtime, so it might not be implicitly convertible to another type. Our example above was implicit. The compiler in this case will make best guess. So it will try. Since the double is simply 3.0, it will cast the int as 3. But what if this motherfucking shit was 3.5? That's not an integer. That's not possible to convert. The answer might crash, or it might just make a 3, or it might go to the nearest decimal. So that's very dangerous. That's a very unpredictable result to let it run loose. So you should not make it implicit. You should be explicit to directly tell how to convert it. Like round down, or round up, or do some shenanigans with it. The other way to convert a variable from another type is explicitly. You can do this by simply telling the compiler what type you want to set it to. So, in our example above, we could change the line a equals b to a equals int b. That way, if b was something other than 3, such as 3.2, we are telling the compiler to make it work, so it set it to 3. This will not change anything on that example I mentioned, but it can avoid some crashing too. Let's take our example above where we want to take the percent score as a double and convert it to an int for display. Set the display score with text score. So here we have two variables, text score and display score. And we want this thing, the display score, to display whatever it is in the text score, naturally. Thus, we need to put a display score to equal the text score. That's what we want. However, the text score is a double, and the display is a freaking int. And convert it to an int for display. You got that thing, it has 95%. Now try doing the conversion explicitly by adding on the int to your settings. So here it's explicit. Take the text score as an int and equal display score to the int version of text score. There's nothing really okay. It's rounding down, you can see just cutting whatever is outside the line, because this is closer to 96, but it cuts everything that's not an integer and ignores it. Not to round. Casting type continued. A more interesting casting option is converting a character to a number type, or the other way around. Just like before, you have to be careful how you set this up. In the back end, a character doesn't store a, it stores the value representing that, 97 for lowercase and 65 for uppercase. Int, target int, character, source character. Target int source character. Now target int equals 97. When you cast an int to a character, you get the opposite process, and the character is set to the value at the int value. So if you did 65, target the character now equals a. Instructions. If a is 95, what do you suppose we would get if we set an int to 99 and cast it to be a character? Let's find out. The initial state is set, so you need to cast or source int to target character. Set the target character equal to source int and explicitly cast it by using character. So We have three variables: a character, an int, and a double. And we have to cast. We set or target character to equal source int. We explicitly tell that we want that source int to be interpreted as a character. Is the character of number 99. It is C, obviously. But it's true from A. Now let's see what happens when you cast a double to a character. Set the target using implicit casting, no type identifier. Target 7. How did they do the loop here? Oh, here is on the difference. They use a for loop. Now, why is A 99? That's because a computer uses bytes. Bytes have 8 bits. That's 8, how's it called again? 8 binaries. So we have 8 things like that. And this is another possible result. This is another possible result. And so on. And with 8, that's 2 reason to 8. So we have 256 available slots. And we use a map to what each slot would be. And that is the basic characters. That's what a character can take. That's why 99 is the slot A. No, 99 is C. 98 is B and 97 is A. 96 is probably Z on the uppercase. So we have numbers, we have upper and lowercase letters, and we have some C. Now I copied this loop to make equal 0 number of loops. Can declare. If I declare this int number of loops equals 10 traces, and as it does so, I want to put the target character to equals y equals e. That's a 0 count. You know, print some shit. So print f equals the character of my character. So the first variable is I. The second variable is my target declaration. of loops is 10. So it will run from 0 to 10, and every time it runs, it will execute this code. It will set the target character to the new y, and you display what the value that is. Let me implicitly call it a character. To put the new line. Now, this is 0, this is 1, this is 2, this is 3, this is 4, this is 6, this is 7, this is 8, and this is 9. Why the hell each things are declared as characters? I do not know. But this is the answer it gives me. If I run this loop 100 times, it will show this, the map of characters. Character 10 is probably tab. It's a big open space. Character 9 is nothing. Character 11 is that male sex thing. It's not displaying the freaking browser is not displaying the things properly. But it's a bunch of weird shit. There's a fucking plus here. This is very much used on older literature to mark the notes of a page. But yeah, really, really shit. This is a character, this is a character, this is a bunch of characters. Now these are more common characters. And the parentheses, application, plus, minus, a dot, a slash, and then at value 48, that 0 actually stands. And 1, the value 1 is actually the value 49, and that is why the value 55 equals 7, do you see? And so it goes all the way to 9, there's only to 10, obviously, that's 2 characters, at least as we use our decimal system. And then it has some more symbols, greater, equal, minus, the semicolon, interrogation mark, at, and then it goes through the alphabet, and then goes through some weird symbols, so it's not uppercase before A, but some weird symbols. Then it starts the alphabet on a minus scale. Now let us see all of them. If you could notice, it stopped on 99. At 100, it the number of loops and did not run again. And the thing crashed. So let's step up at 100 and see from 100 on. Cannot fucking do that. Oh fuck. Let's hit 200 then. What? Not running my C code. So I will just put that code here. Offset, it has the int main, it has the printf, and it returns 0 because yeah. Now I declare this, but I do not have a declaration of this target. It's a char, target is char, exactly like that. As you can see, this thing is very helpful program. As I was typing, like if I start to type here the number of loops, it shows there is only one variable that could possibly mean with none. Oh well, yeah, none can work. If I put only null, I can might mean a continue, I might mean a new or include. So it helps me like completing shit real quick. It's a programming thing, and I can run it. As you can see it, open the console here, show the same thing, but even worse than before. It cannot display this character of 0 and of 1 and all those crazy characters. Display the normal characters, skips the crazy ones, and go to the numbers, to the symbols, to the alphabet. Normal ones here. Fails at this one. Show the alphabet in lowercase. And after Z, we have these. We have the comparative bar, the bar. We have our keys. Then we go through a bunch of random shit that this thing cannot display. It cannot freaking display me, the actual thing. But as you can see, there is a map. It's the map BT map index. So that BT, the pipe. Yeah, ACC. That then is the ACC. Yeah, probably use it. There's some node, there's some symbols. Then let's start here. We have here the other thing. There are several maps actually. The one we use today is the axis. But here we go. That's why it displays those things. Review. In this lesson on variables in C, we learned the rules for naming variables in C, the main data types in C, int, float, double, and char, declaration and initialization of data types in C, as well as how to change their value, how to cast from one data type to another, and some potential limitations in C. We went over a general introduction to variables, but there is much more to learn. You should now have the building blocks we will add on to. In the next lesson, we will go over more options. You have with variables, such as arithmetic comparisons and logical operators that will allow you to expand on the power of variables in C. Thank you for joining us, and we can't wait to dive into the next lesson. There are some quiz and some little project for a grocery store, but it's for operators. In this lesson, you will learn about performing basic mathematical operations on variables and values using common symbols, assigning values to variables and/or performing basic mathematical operations using shorthand operations, comparing two values and/or variables against each other to return a true or false, using logical operators, and/or and this is a shorthand. In the previous lesson, you learned how to create a set and set variables, but not what you can do with them beyond that. In this lesson, you will learn about modifying variables with the power of math, some shorthand assignment methods, and how to compare variables and values. Finally, we will go over how to use logical operators for and, or, and mathematical operations. At their core, computers are basically fancy calculators, so it's a good thing to learn how to perform basic mathematical operations early on in your language development. Addition and subtraction work just as you would expect them to. A equals 2 plus 3. You will store 5, the variable A. You can also use these variables as part of the math or all of it. The same foundational principles of mathematics hold true for subtraction, multiplication, and division. Now we can add a little flavor to our variable knowledge. The program on the right already has the declaration of the variables and some values set, as well as the output to display the final results. Your task is to modify the values stored in the variables using mathematical symbols given any change. It was a good week. You sold 200 more books. Updated the books sold accordingly. So I have to increase it by making the changes here. That means it's not very clear what it's meant to do, but it's telling me to do this. Telling me to come here, put books sold equals plus 200. Is that what it's telling me to do? Or is it telling me to put books sold as books sold plus 200? Anyway, I'm going to use the shorthand right on the back. Now it's sold 300, you see. I added 200 to the original value. This is the shorthand for this, which is the lesson, so that you do not see those silly error messages. Now that you have the updated book sale accounts, calculate the total sales value. The total sales value. So the total sales value. No, I think this straight. Books sold. So books sold is equal my initial books sold, gold variable plus 200. And the total sales value is naturally the number of books sold times the cost of those books. So that's almost 3,000. Each one costs almost $10 or 10 some value. Your publisher takes half of the total sales as part of the cut. You update your total sales accordingly. You can do this with multiplication or division in the real world, but for practice, please use division. I'm just going to use multiplication. Update it. It wants me to declare a new variable? Or what? Total sales value equals total sales value divided by 2. Naturally, like this, the shorthand version. It would naturally just multiply by half. This is it. You can write the variable again. Let's do these operations, or you can use the shorthand version of it. And that's about it. Modulo. This shit you do not usually use. Something that's a very powerful tool. You may have run across modulo. symbolize it as the percentage symbol before. If not, as a reminder, modulo performs division, but instead of giving you the number of times the denominator goes into the numerator, it gives you the remainder after division. As an example, if you took 10 of 3, you would get 3 with 1 left over. If you wanted to get the remainder and didn't care about the other part, you would do 10 modulo 3. This would give you 1. So it tells you something is something. For example, if you do the model with 2, it tells you if it is an even number. A common use of modulo is determining if an integer is even or not. Oh, that's what I just said. If we have an integer, x, and aren't sure if it's even or odd, we can use modulo to use the remainder. If the result is 1, x is odd. It does not fit into 2. 2 does not fit exactly into it. Otherwise, it is even if it fits several 2's without leaving anything over. Modulo can also be used to determine the day of the week, given a start and an end. For our exercise, we are going to assume that we are starting on the first, represented by 0. First day of the week, and we want to figure out if any program started 13 days go by. What day of the week is it now? For the first step, set the initial value of days that pass, any positive integer you like, and days in week 7 during the declaration. What you have to do? Not sure, but it is pretty clear. The instruction on the end. Set the initial value for days that pass. How many days do I want to have passed? Let's put some 50. And a week, that's 7 days. So it will not print. We started on the first day of the week. Went, days had passed, 50 days. So it is now the day of the week. Ending day of the week. Day of the week is 0 days of the week. It shows 0 because it's 0. To fix that, I need to show what day is it in a week after 50 days. And to do that, I use a modulo. How many 7 can fit into this? We know that 7 is 8 will give us 47. Is it? No, it's not. 5 times 9. 7 times 1. 7 times 8 is 16 something. 7 times 6 is 42. 7 times 7, that's 49. Yeah, that's what I had in mind. It's 49. So it will fit 7 sevens in here. And there will be 1 left over. So the answer here, when I put the modulo, will be 1. And I'm on day 1 of the week. That was left. If it was 55, the remainder would be 6. So I would be at the 60th day. I would be at the last day of the week. And if it was 66, the remainder would be 7. But a 7 can fit in 7, so the remainder would be 0. See? Your task is using modulo logic to determine the day of the week to be after any days pass. Store the result ending day of week. So the days that pass modulo days in week. So how many weeks can fit in this? And after all the possible weeks are fit, how many days are left over? That is the day I'm in. Oh shit, it crashed. But it gave me a right one. Value required. Oh, I made some crazy operation here. But it give me a right one. It's the first day of the week. You see, as I mentioned, if I put a 5, it will give me a 6. 6th day of the week. It's that operation I just mentioned. How many fit in and what is left afterwards. Some very niche operation. They always teach it, even though I have used it. I've used it before, but did not use it much. C has several shorthand tricks you can use to make your life easier. For instance, it is very common inside a loop to have a counter you want to increment, add 1, or decrement, subtract 1 on each pass. C lets you do this by using a double symbol, such as that. This would now set the value of in A to be 2. The shorthand for decrementing is minus minus instead of plus plus. So if we wanted to decrement A, it would be A minus minus. Decrement, what the fuck is this? Using shorthand. This is an M. So M minus minus. The absolute shorthand. That is a decrement. It's take only 1. Now do the opposite. Increment using the shorthand on N. So N incremented 1 and this decremented 1. So this is identical with putting minus equals 1 and plus equals 1. See? But as you can see, there is one extra character here. It's more complex. But now I can put it at 2 or at 5 words. While this obviously is just for 1. Increment to decrement. It's a single point. Assignment. It's one thing to do all these operations, but if the results are thrown away as soon as the statement finishes executing, the entire process has limited usability. What we need is a way to assign values to variables. We have already seen the basic way to do this using equal, but C offers some additional shorthand tricks for assignment. Each of the basic math symbols you have learned in this lesson can be done in C with a shortcut. Let's look at an example of 2 ways to write simple addition that would give you the same end result. Int a equals 2, int b equals 3, a equals a plus b. This could also be written as a equal a plus equal b. It's the shorthand I have been using. Notice that C lets us shorthand adding something to a variable's starting value by using plus equal. You can do this same shorthand with less equal, times equal, slash equal, and modulo equal. Also with subtraction, multiplication, division, and modulo, respectively. I find it very insane that modulo exists like a symbol like that, but you cannot raise something to a power or take the derivative of something so easily. I have to call an entire function to raise this shit. In the example, we showed how to set a variable to itself plus another variable. In the code block on the right, find the total losses by multiplying losses by time servers crashed using the shorthand method. So, my losses every time a server crashes, I lose this much. The servers crashed this number of times. Server times server crashed. So it will give me this great number here. You find out that the losses calculated per crash were far too high. In fact, they were estimated at twice what they actually are. You predate your losses to be half what you just calculated in the previous step. You still use the shorthand assign method. What do they expect me to do? I can just put this thing here, but they want me to use losses by 2. That's what they want me to do. Comparison. You have to learn about the statements that check on and respond to true or false, known as Boolean values yet. But since we are talking about arithmetic symbols, we wanted to give you a primer with the symbols used for these checks. You can check if two values are equals. Notice there are double equals to check for equivalence rather than the single symbol used for assignment. Not equal, greater than or equal, less than, and less than or equal. As an example, if you wanted to perform a segment of code if A had the same value as B, you could write it as if. Notice in this code that at the end A would be 4. So at this equal, both are 3, so they are equal. So A is increased by 1. There's an increment at A. There is some very silly programming jokes that the programming pages post. That is about the difference between equal and equal. I do not understand them because they are so retarded. Like, use it to check equality and you use this to assign a value. They are completely different operations and it is not possible to confuse them one with the other. You are making A equal to something, you are comparing something that, no. So, yeah, extremely easy, that is not to be confused about. But here we go. The code block is ready for your new knowledge to fix this bad code. Insert the missing symbol in the if statement so that the logic inside the check runs and the output is printed. Note: you will learn more about if statements in a future lesson. For now, you want the statement inside of it to be a true statement. So you want to use logical symbols such that the comparison between x and y is a true statement. So I have to make this true. And need to print congratulations on setting up a comparison correct. To make it true, I have to establish a relationship between x and y, and one that is true. Is x equal y? No. X is 5 and y is 42. They are different. Is x greater than y? No. It is x that is less than y, minor than y. It's minor or equal. It runs true. If it's like that, it's false, it will not run. And if I make it 4, it will run. Because it's now less than x. So if I make it equal and make it 4 now, it will run. But if it was 5, it would not run because they are no longer equal. Logical operators. You do not just have to check one part at a time when you are doing your comparisons. C lets you see if 2 or more parts are true, if at least one is true, or if something is not true. We have already seen a quick example with not This means not equal. Check to see if the left side is not equal to the right side, but not in front of any boolean. You see if the statement is not true. You will learn more about this when you learn about boolean statements in general. If you are checking to see if two or more parts are true, you can use and between them. If you want to see if any of the parts is true, you can use or. You see both in action here. Here is you see both in action. Here is a trivial example. A equals 2. B equals 3. If A equals B and A equals 2, both are true. If A equals B or A equals 2, one or both are true. If A equals B is false, they are not equal. If A equals B is false is true, they are not equal. A equals, if A does not equal B is a true statement. In this example, only the second and third statement would evaluate to true, because A does not equal B here. It's not wrong. Here, A does not equal B, but since A equals 2, this OR evaluates to true. This is true because A does not equal B. So A does not equal B is a true statement. A equals B is false is a true statement. The books of Aristotle on logic, the Organon, he talks about that. In fact, he uses actual object-oriented programming to describe how language works 2,000 years and 2,300 years before programming was invented. The colonel right is set to output the corrected text when the values are equal. But you can see they are not. Change the if statements to evaluate to true when the variables are not equal. So they are equal. It will show congratulations. Else, please try again. I can make them equal by changing it, but that's not what I want. I want to change this so that I make it true. No. If I put it at the minus sign, I will make it true if I substitute this for the minus sign. But what it tells me to do is to make this evaluate if they are not true. So I put the not in this, not this. If this is statement that x equals y is false, is true, then run this code. Watch, I just do. Put this thing here because I'm retarded. Okay. If x does not equal y, then do this. That's more simple. Do that shit that I just tried to do. I will need to encompass this as the main statement and declare this statement has a boolean that's not true. Yeah, that's what I did before, but I did not put the order of operations. C does not just process the statements you send it blindly from left to right. It looks at the statements and applies standard rules to the order in which the statements should be processed. For instance, it will do multiplication before addition. There are many more symbols and operations you will learn as you progress with your knowledge of C, But here is a list of the order of the operations we have gone over in this lesson. Looking at the table below, the operations with priority 1 will be performed first, then priority 2, 3, and so on will be processed. For operators of the same level of priority, operations occur from left to right. This pronoun here should be the possessive pronoun, should be in the genitive. Operations is genitive, it belongs to them. Typecast. These have the same value. Being minor than something. Oh, they have this thing also. They're the same thing. All of these are the same thing. But you do not trust the order of operations on those Instagram posts and Facebook posts and everywhere, really. They put those little equations. 2 equals something times something. What is the answer? This or that divided by something. And the thing is, they have no answer because they are ambiguous. They do not show exactly how to be performed. So they have many answers because no answer is correct. Here you know that 3 times 5 runs first. Because 3 times 5 is 15 plus 2, 17. This thing is a single one. You have 5 degrees to sum with 1 2. You do not have 5. But you should not never trust this order of operation. That's not how anyone does anything. If you want to specify what is happening, you have to put this. You'll never write this shit without parts. Parentheses. The code on the right is using the order of operations described above. So the variable x. So for the variable x, it will do the multiplication first, then the addition. However, we want the addition to occur first. Please fix the line of code to tell the computer to do the addition first for a value in 2x. So I do not want to have 2 plus 5 3's. I want it to be 5 5's. And to do that, you put this. Now, 5, which is 5 times 5. Now take a look at the y equation. Notice that it will do the division first, and as an int, you cast it to 0. Then at 6. As an int, you cast it to 0. Then at 6. Update the line so it does the addition first, and resolves to 0. Cast it to an int. So if you do the addition first, so I have 10. I have 2 divided by 10, which is naturally 0.2, and has an int that will be at 0. Review. Congratulations on finishing this lesson on operators in C. In this lesson, you learned about basic mathematical operations in C. Addition, subtraction, division, multiplication, incrementing, decrementing, and modulo. Assigning values to variables equal, plus equal, minus equal, times equal, slash equal, and modulo equal. Performing basic operations between values and variables. I'm not going to read that. Using logical operations in C, and, or, and not. You now have the basic tools on which to build a strong understanding of coding in C. We have gone over a lot of very important foundational ideas. We encourage you to spend some time playing around with them in the console on the right. cannot print this, man. I believe the C sharp would print it. I was actually expected to be printed. And now it can. Insane shit. So, as I mentioned before, as you cast a variable here to be printed, it will recurse the first variable. And the variable does not need to exist. You can declare it right here. I can just make a literally. Or I can make an equation of 1 plus 1 that you happen first times 3. Now it will print 6. Could play with the if statements too, but it will probably teach them now. Yeah, conditionals. Every programmer we have seen so far has only had one possible path of execution. That's a lie. We have used several of conditionals. They all execute line by line, from top to bottom. And every time you run one of those programs, it gives you the same exact result. But it's the 21st century. We like options. In this lesson, we will introduce logic to our code and explore how programs make decisions by evaluating conditions. We will be covering the following concepts: if, else if, and else statements, switch statements, relational and logical operators, ternary operators. So, if you have already learned these concepts in another language, go to the next lesson. Else, prepare yourself and let's get started. Coin flip demo. Before we dive deep into the syntax of if statement, let's do a demo. Here we have a coin flip.c program that simulates a coin toss. 50% of the time it's head, 50% of the time it's tails. Run the program twice to see an if-else statement in action. How many times did it go? Heads, tails, heads. Should I break down the program? Should I just ignore it? It will not teach the program. It includes the usual shit. It includes a new library. It includes time. So there's a main. It creates a number that's 0 or 1. Time. No. It's a rand. It is some function that I do not know. Oh, it's a random number generation. It creates a time that's 0 or 1. And call in passes that to time as a null. Then declares an int called coin, and it randomizes that. And whatever random number it got, it sees if it is odd or even. So it will give either a 0 if it's even, or 1 if it is odd. If the number is 0, heads. If it is not 0, tails. So it checks if coin equals 0. So if the modulo of 2 is 0, if it's even, it will print head. Else, if it's not 0, it will print tails. It's random. What the fuck is that? That is some function that exists within one of these libraries. These libraries can tell how many times it has been run. So after you run the game twice, run the game once and other times, you affect this function somehow? Apparently, because this rand is also a function of these libraries. We would need to open these libraries and see exactly what the functions tell the program to do in order to fully understand these two lines. But it's basically this. Randomize the coin and take in consideration how many times the program has been run in order to alter the result every time. Here it checks the result if it equals this number or else. If statement. An if statement is used to test an expression for truth and execute some code based on it. Here's a simple form of the if statement. If condition statement. If the condition is true, then the statements within the if block are executed. These statements are any lines of code that would otherwise be normally executed by the program. When the condition is false, the inside statements are skipped and the program continues on. So if you just write shit like this, right, it will run them. But if you put inside the statement, it will only run them if the statement is true. If it is false, it will skip over then and go to the next line. It checks the condition. So if flip equals 1, it will show heads. The if keyword is followed by a set of parentheses. Inside this parentheses, a condition is provided that evaluates to true or false. If the condition evaluates to true, the code inside the curly braces executes. If the condition evaluates to false, the code does not execute. So in the code above, if flip is equal to 1, the program outputs head. If it does not, then nothing happens and the program continues. Write an if statement. So if it checks, so the condition is grade 1 is greater than 60, is true. And if it is, it will print f pass line. Close the statement. Write another if. The condition inside the parentheses is if grade 2 is less than 60. And if it is, inside the keys, it will print fail. Close the statement. Some shit happened. Grande 2, I put an extra letter there. It runs. Requires no explanation really. I suppose, I believe in that. Already self-explanatory. The variable if is even in English. Working with operators. We have already seen relational operators at work. Conditionals incorporate them in other forms. For example, we can do something like if grade equals or greater than 60. Greater or equals than 60. Do some shit. In much the same fashion, we could have used a minor or equal, or not equal, or even equal. These relational operators naturally result in true or false expressions, which makes them perfect for conditionals. However, sometimes we need to write multiple conditions in one conditional statement. In a past lesson, we have learned about logical operators. We can use these operators here as well. Let's recap the logical operators, and, or not. So, the point of a condition is to tell true or false. Those are the only possible results of a condition. A condition is either true or is false. Can be null, but yeah. Some statement, something that you evaluate is either true or false. And we check that by using this. We want to see if something about that relationship of them is true or false. And you can use also the logical operators to make more complex conditionals. As we are going to see. When placed in a conditional statement, logical operators work together to produce one true or false output across multiple conditions. We check it all and gives you the verdict if some event should happen or not. For example, if A is greater than 0 and B is greater than 0, then you say positive. The above statement checks if both conditions are true, and if they both are, the if statement passes. If either A or B was a negative number, the if statement would be false. So both have to be true, because there is an and. It requires these and these has to be true. If any of them are false, then it's not positive. Not all numbers are positive. Change the logical operator in the conditional statement from and to or. What do you think will happen? So now, if A is greater than 0 or B is greater than 0, so if any of these is greater than 0, then it is positive that that is a greater than 0 number. Now, my keyboard, once again, not have this thing. Just as you can get this by using Alt plus 95. For that, you press Alt, keep press it, and it will do that. You can use Alt. What is it? What the fucking shit? I forgot. I began to explain. I began to think about it, and I forgot. Holy shit! It's something with 102. 122. That's the Z. Oh, my hand goes again. Well, let me copy this shit. If I think about it, I forget. I have to go just my mind. I actually saw that when I asked it for the AC cable, did I not? Nah, that's not it. 24? That's not it. Yes, it is. So if you put Alt plus 124, you get this thing. Now add another if statement that checks this is. Now add another if statement that checks if both A is greater than 0 and not is greater than 0 are true, and print positive 2 if they are. If A is greater than and an end, to do an end you can just press shift and the 7 up there. There's an end to the side of it. An add. And it is false the condition that B is greater than 0. So if A is greater than 0 and it is false that B is greater than 0, it will print that it is positive 2. Close the statement. Things are getting cool now. Else clause. We can also add an else clause to an if statement to provide code that will only be executed if the initial if condition is false. It is a form of an if statement that includes an else clause. If condition statement do something, else statement do something. If condition is true, statement 1 is executed. Then the program skips statement 2 and executes any code statements following that clause. If this is false, statement 1 is skipped and statement 2 is executed. The program executes any code statement following that thing. entirely pointless. But yeah. So if it is true, you do this thing like always. Else, by the explanatory, it will do something else. It is not true. If the if is false, like the coin thing. In the code above, if coin is equal to 1, the problem outputs health. Else, if coin is not equal to 1, prints this. You can also put an else if. It's either or. Only one of them will execute. Add an else statement that prints fail. So if the grade 1 is greater than 60, passes. Else, that is, if it is not greater than 60, it prints that he failed in a new line. Close the statement. Add a second if else statement with the condition of grade 2 with the same things. So I can just copy this and change this to 2. Now this evaluates the grade 2 and he passed. This is the other thing. Before the grade 1 passed and 2 failed. Now grade 1 failed and 2. On a previous lesson that is. They are balancing those poor guys who are losing. Who are failing. Else if. So what happens if you want more than 2 possible outcomes? This is where else if comes in. The else if statement always comes after the if statement and before the else statement, if there is one. Like the else statement, else if statements are also always optional. The else if then takes a condition. You can have more than one of them. Here is an example with 3 of them. If the grade is 9, is a freshman. Else if grade is 10, is a sophomore. Else if grade is 11, is a junior. Else if grade is 12, is a senior. Else is a super senior. So else always runs if nothing else runs. But without the else, those things would only run if some of these are true. So if it's an 8, none of these will run, but else will. If it's a 7, none will run, but the else will. Nothing else runs, the else runs. Because that's the freaking else. In chemistry, the power of hydrogen is a scale used to specify the acidity or basicity of an aqueous solution. Write an if statement that checks if the power of hydrogen is greater than 7. Then print the basic if it is. If it is greater than water, I think if I put a water here, they will. Oh. But I put it just to check it. I create an integer called aqua and I will put it to 7. Now my if statement checks if the pH is greater than the pH of water, which is 7. That's what I want to see. And if it is greater than water, then it's freaking basic. And if you print basic, else it's acidic. It's an acid. Close your statements. The thing did not like me, something crashed. Those are several problems. Function main 12. I forgot a shit here. It works, but the game did not like it. If I put this below, but the game did not like it because they did not want me to do this, they want me to do this. Silly game. Change double PAG to something lower. Now attach an else if. An else works, man. Okay. to be base and acid, base and acidic. They are on the adjective. Change to 7. Nothing will run. Yeah, that makes sense. Now the else will not run. Yeah, it would tell it was an acid. It was exactly 7. Add an else. I have to add an else. So printf milk aqua. Switch statement. Now that we know how if, else if, and else work, we can write programs that have multiple outcomes. Programs with multiple outcomes are so common that C provides an special statement for it, the switch statement. A switch statement provides an alternate syntax that's easier to read and write. However, you are going to find this less frequently than if, else if, and else in the wild. Less frequently means that basically no one uses this thing. I actually use it, it's kind of pretty. I can just shove it all on a single line. But yeah, if and else if are much better to work with. Because on an else if, you can put several complex conditions. And these, you basically put a single line, you have no parentheses, no order, wild and chaos. Wild and chaotic. They are adjective forms. The switch keyword initiates the statement and is followed by parentheses. So it is initiates shit and it's evaluating a conditional of grade, which contains the value that each case will compare. In the example, the value or expression of the switch statement is grade. One restriction on the expression is that it must evaluate to an integral type, integer, character, short, long, or n. Short, long, and long are kinds of they are numbers. A short is a short number. A long is a long integer. The long is a very long integer. Enum. What the fuck is enum? An enumerator? That's a kind of object shit that you put on things. Oh. Okay. What is the enumeration of objects that you use? Well, inside the block, here, entire shit, there are multiple cases you can see. The case keyword checks if the expression matches the specified value that comes after it. The value following the first case is 9. If the value of grade is equal to 9, then the code after this will run. The break keyword tells the computer to exit the block and not execute any more code or check any other cases inside the code block. So it leaves the block and executes the rest. The rest of your code outside the block once it meets a match. Something important here is that it can be effective. If you had several else if, you would need to check them because it could not know that they were all evaluating the same thing, the same grade. But here it knows, and so it breaks away. And if you erase this break, it will actually execute the following code also, and can fall on. That can be used as an next strategy. At the end of each switch statement, there is a default statement. If none of the cases are true, then the code in the default statement will run, just like else. This is essentially the else part. The code above suppose grade is equal to 10. Then the output will suffer more. Note, without a break keyword at the end of each case, the program would execute the code for the first matching case and all subsequent cases, including the default code. This behavior is different from if-else conditional statement, which executes only one block of code. So perhaps you want to fall down on it. So you always execute the lower codes, but check if you want to execute the first ones. But that's a more complex behavior. And as it says, very few people actually even use it, switch statement. So much less you'll find that fall down behavior being used. Here we have a switch statement. Let's add 3 more cases right before default. Case 7 that output is Scuttle, case 8 that outputs Wartortle, and case 9 that outputs Blastoise. So just copy this shit like a normal person. Yeah, like that. And rename the cases and the thing. Something funny is that he is not mentioned this thing. The output has to be Scuttle, and this is not outputted, so it's perfectly right. But before, they included this on the instruction of the output. Remove break from case 7. What do you think you run? You literally said that you run everything afterwards. Did you say Wartortle, Blastoise, and Unknown? If you only run this one, so they are wrong. Because they say, in all subsequent cases, including the default, but did not run it all because of the break, obviously. I expected this to happen, but since it said it will run it all, I accepted it because I do not use program on C. I use the C# mainly. But yeah, if you go on to the next break word. So if I take this out, it will show all the transformation of a square. Like this. There's a fall down. If it is 7, it will show 789. If it is 8, it will show 89. And if it's 9, it will only show 9. This is some complex behavior that can be simply programmed if you have enough control to do it. Ternary operators. We have learned that the if and else statement is versatile. So it's so versatile that C actually has a built-in special way to shortcut an if-else statement into one line. And you don't even need to use the words if and else. Do not use ternary operators. That thing I just mentioned about the switch case found now, do not use it either if I work on a company. They will fire you. If you write this kind of shit, they will fire you. It's not very readable. It's meant to be shorter, but it's actually a mess. And you don't even do it. The shortcut is called a ternary operator. It's most applicably used when an if-else statement returns a value, but can also work otherwise. For instance, deciding what to output in a print statement. A ternary operator looks like this. It's a condition. This is the condition. Is A less than B? There's a interrogation mark to mark you are doing a ternary. It's asking if this is true, literally. And if it is, do this shit. Do A. It's return A. If not, return B. So min will be equal the result of this thing. If this is true, min will equal A. Else, if B is not true, min will equal B. The above example is exactly the same as if the condition, then do A, else B, do something. The standard operator acts exactly like if else statement. For example, let's take a look at the following statement. This is this statement here. If A is greater than this, is it? If it is, then me equals A. Else, if it is not, me equals. The above if else statement compares A and B and stores the smaller of the two inside the mean variable. Because if A is smaller than B, if that is true, it's A. The only way this is not true if A is either bigger than this or equal than this. Which case return B. A little b is smaller or at least equal to. There's a preference for beaming racism. The interrogation marks the check for the condition. And if asking it has a question. As if asking it has a question. If A is the smaller number, the condition passes with true, which executes the left-hand side of the column and stores A into min. If the condition was false, then the right-hand side of the column executes, which stores B into min instead. Run the program to see a ternary operator in action. You see two numbers in the output. The first demonstrates how the ternary operator can return a value, just like the example above. The second demonstrates how the ternary operator can be used without returning a value. So this, if A is minor than B, then print this thing with A. If it is not, then print this thing with B. Sure. Review. Congratulations on completing the lesson on conditionals. Let's review some of the major concepts from the lesson. An if statement checks a condition and will execute a task if that condition evaluates to true. If else statements make binary decisions and execute different code blocks based on a provided condition. We can add more conditions using else if statements. Relational operators, including all these things and not equal, can compare two values. Logical operators, including those things, can allow multiple conditions in one conditional statement. A switch statement can be used to simplify the process of writing multiple else-if statements. The break keyword stops the remaining cases from being checked and executed in a switch statement. A ternary operator can be used to simplify the process of an if-else statement. Optional. Little Mac is an interplanetary space boxer who is trying to win championship belts for various weight categories. How to pronounce this shit? Categories on other planets within the solar system. Write a space.c program that helps him keep track of his target weight by it should ask him what his Earth weight is. Ask him to enter a number for the planet he wants to fight on. It should then compute his weight on this destination planet. Compile and execute. What do you mean it should ask him, motherfucker? He should ask him. What is the information for the input? I should put the input here. I have no idea. Print F. Input F that I ask for an input. Nah, I just declare that shit. I do not ask him. Because you can ask him to input something here on the terminal. That's not the case, I just make it. His weight, yeah, double. equals is wait. A number for the plant that wants to fight. And that's an int. Plant equals some number. They declare this shit wrong. Not really. It's rate like about 60. It's going to the Bantam class. And now I have to write a switch statement. Switch statement that returns those weight. So switch is weight. No, switch the planet is going in. Its weight is interval. In case 1. Return f it is. Oh, I have to add the code of these things. And I declare a vector here. Make my life easy. But I declare a vector on this thing. It's an array. Let's show me the declaration, boy. A vector. How many shit I want. So you declare a double graphs vector which takes in these values. I'm filling in order, separated. A vector it starts at 0. So I'm putting at 0 and I'm passing the first one as Mercury, 2 as Venus, and so on. So now what I can do is this. I can call this double array number like lives and the number I want, one which is Venus. But since this is the planet already, I can just call the planet a variable and multiply this by my weight. I can break it. Because I have not hard coded any shit. I can literally just change the case number here. And they will correspond. Because if the case is 4, it means that the planet is 4. And so it will go on the array and take the 4th planet and multiply on the weight on the case. Now it has a switch that prints the weight. This is it. I have to go to the planet now. So let's make the freaking off loop aqui. Because I want to run this thing several times. Not this pop. I just declare the planet here and they test the code several times. It told me to compile it. It cannot run, I have to compile this thing. How we freaking enter the planet? Scan. I have to use this thing. Scan. I have to actually ask his weight. I just declare it and I have learned this scan. So it will scan my answer on the console. What the fuck is this scan? I cannot just put weight and equal the scan result. I have to do this shit? Are you serious? I want to do this. Let's see if it works. Print information. Native. New lines. I need to print the destination table, but that's a pain. Very front end. Let's give it very. The other one. Any planet. Now it's your names. Change the freaking weight. That's one way to do it. A simple print statement on everyone. That you print it. And then the program. So this is a thing. And I have to compile it. To remember it. The GNU thing. GCC, how is it called? Space .c. The name is right here on the file, on the folder. If you click on the folder, you can actually see the directory, all that there is. And after I compile, there should appear a new thing here on the directory. Like I put the name of the Manage it. Something happened. Type it double. Okay. It expects to round it down. C. Double in each string. What do they use? They use that df thing. The plus plus. Convert a string to a double variable. Ret is a double. They use a freaking D or LEF. Floating point. Silly. This is very silly. I mean, it's really stupid. Not even Python is so stupid as to discriminate to which letter I use for my variable inside a string. Expected. Oh, yeah. I forgot to close my statements. So much here, oh man. The 14 now. No, it cannot go. This argument does not work. I have to organize it like they did. I have to come here, put this silly thing. That's be an LEF because I'm using a double and equals it to the weight. So very. Now once again, if you want integer and to link to the planet that they want, there it is. Created the planet program you can see here. It's on machine code. And I can run it by running the planet program. Except that I have to specify the directory. That is the root directory I'm in and planet program. Not execute binary file. Compile. End to the switch. There's some error message now. Why is that so? I just compiled this thing without error message before. Argue format y expects argument of type int, but argument 2 has type int. And they put some edge. I have no idea what that is meant to be. But who knows? I was not explained yet. Now it made this the planet program dot out. I can run this thing dot out. Cannot execute a binary file, man. This thing is trolling me. You cannot execute binary file. Compile to make the next run. Okay. Oh, it already runs. What the fuck, man? It's crazy. It asks my weight. Let's say I'm 500 and tell me to select the destination very correctly. That's why I went through that trouble. I put 500, so we know that if I put 3, it should give me about a third of my weight. A little more than a third. So it should be almost 200. 3. Let's see. Yeah, almost 200. There's a freaking S at the end for any reason. But okay. That's the LEF. The only F. Floating points. Run the program again. I can actually make a loop. Make it cooler. So now the class shit and yeah, making a loop is so troublesome. Like, I'm not sure how I make a while here. There's a do while. Thinking up, teste, velho. Olha, char, load, equals 0. Equals yes. Do while load does not equal y or while word does not equal y. Is there a name to this statement? Y. So now if you do this inside the code, and at the end you ask me oh, let's compile it. How do I do it again? Space.c file to take x. some error is happening. Or there's a freaking word here. Anything else? Forgot a P. It compiled. Now put run jkx. What the fuck did you just say to me? No space. Put no freaking space. Forget me. There. Separates by one line as I put. I can choose any weight, like 100. I can choose the lines, it gives some space. Not suffice. And let me put Uranus 100, so it will give me 92. 92. 14 points. And it went to wait. Did not ask me print. Okay. Why did not run? Asking some wait this shit. What the fuck is happening? Well, abort. It started to run by itself, man. It has gone crazy. But you see how pretty it is? Did you ask? And anything I type, not only any, will make it to run again. But if I type Y or minor Y, you exit the loop and end the program. But while I do not end, I can answer this question, repeat, and check all of them. Well, enough playing around. I have to sleep. It's 1:30 in the morning. So let's move on. Introduction to loops. A loop is a way to repeat code or a set of instructions until a specified condition is reached, which is what I just did. For example, have you ever been looking for somebody in a grocery store? You check each aisle until you find them. You naturally perform certain tasks with a repetition or iteration until a condition is met. In this case, when you finally catch that glimpse of a familiar person. The generic term iterate means to repeat, iterate. You will find that, just like in real life, you will use loops in your code all the time. And just like this infinite GIF of blocks turning, a task may repeat seemingly infinitely, but you always have a way to control when it stops. Games are just loops. You always go back to the main loop, and that's what you do. The main loops keep running and expecting a command. When it receives a command, it does that action like walking, attacking, or doing something. Then it goes back to the state of rest of the main loop. And when the loop ends, it's exit, the program ends. When we see that a process has to be repeated multiple times in a row, you write a loop. Loops allow us to create efficient code that automates process to make scalable, manageable programs. In this lesson, we will learn about 3 types of loops: while loops, do-while loops, and for loops. It is using the scanner, it's only teaching it now. Interacting with a loop. Before we dive deep into the syntax of a loop, let's do a demo. We have a program that asks and checks for a pin. It uses a while loop, while which will be the first type of loop we will learn about. To ask the user to type and enter a pin over and over again until the correct one is entered. As a reminder, here's how to compile and execute your code. You don't need to understand the code yet, just how to interact with it. enter pin underline enter underline pin dot c. As you can see, it's up here, this thing, and it made the basic thing the root. The default name is out. We check it, put in space. Bank of Codecademy. Enter your PIN. So it asks you for a PIN. If I put any PIN, it asks again what is the correct PIN. 0. No, it's not 0. 0 is the default, it is set in tries plus plus. Each time I try, it does this. If I put it again, so here, while the PIN is not is 1, 2, 3, 4, and the tries are less than 3. I just did my when it enter your PIN. Scan what I put. Put one more try. If the PIN is right, PIN was accepted. You have no access. It is wrong. Just close the program. It closed the program. It reached the end without nothing happened. Yes, the while broke out. You have to repeat in it. Enter your PIN. Enter your PIN. Enter your PIN. It was not. You see? Went on. As it is 0, it entered the while. It's true that the PIN is not this number because it's freaking 0. And the tries is 0 also. So I entered here. It asked me to enter it. I put a number. It increases the try. Try to leave, but it could not leave because the condition is still true. So it repeated. But once it repeated, the third time it was no longer true because the tries are now 3. So it left. As it left, the PIN was not this number. So this did not run and the program ended. If I put the right PIN, if you leave because this condition is no longer true, it is true that it is the number, but not false. So it runs this, accepted, and I have no access, and the program ends. This is all that is happening here. It's telling me to put some wrong numbers and see the right one. Guess the number. Now that you have interacted with a loop, that's the right one. The while loop looks very simple to an similar to an if statement. And just like an if statement, it executes the code inside of it if the condition is true. The difference, however, is that the while loop will continue to execute the code inside of it over and over again, as long as the condition is true. Here's a simple form of the while loop. While condition statement. In other words, instead of executing if something is true, it executes while that thing is true. If this while the guess is not 8, wrong guess, try again, modify the guess. This link, the answer, the output, the same memory slot as this variable, as the variable guess. I suppose this end is doing that magic. So if you change guess by this means, not by equaling guess to some input, and then if you check the condition, if it can leave, while the condition, while this thing is true, while it holds true, if you keep repeating. In this example, the program will keep asking the user to input a new number while guess is not equal to 8. If you exit the while loop once the user types 8, allowing the condition to finally become false. So if it becomes false, you cannot repeat. and let the program continue. On that program, on that planets, I put a do while. It crashed for some reason, I do not know why. But yeah, I do while executes the first time, always, as if it was on the block of the function. And then it starts repeating based on the final condition and becomes a normal while. The difference is that mine guarantees that the first time will always execute. Yeah, while if I declare the guess beforehand and put it on a condition that's not what you break. So, note, the checkbox will be had until you input. You have a program that asks the user to guess a number between 1 and 10. The answer we're looking for is 8. Run the program a couple of times and try guessing wrong. Guessing wrong numbers first, then guess the correct number to get a feel for how the program repeats itself. A reminder, here's how the compiler and execute. So we have the main function. We have two variables, guess and tries. It prints, I'm thinking of a number, the range. Try to guess it, and ask me to guess it. A while looping here, I have to write it myself. The guess is this exits. You got it. I have to write it or I have to run it? I have to run the program several times by typing it. I have to compile first. No, there is an a dot out. A dot out. It left the thing. It told me and left the thing. Now instead of just asking the user once, let's add a while loop to handle the repetition of guesses. Limit the loop will allow up to 50 tries. My loop crashed before, I still unsure what happened. But I find it very silly to limit the tries. Let them be happy. The gaming loop has to loop millions of times. They give me the freaking code, man, I can just copy it. After adding, compile and execute it. Can I make a different code? I can change the guess. You run infinitely, and if they get it right, it will run this thing outside. This does not need to come in. In fact, putting it in will check the if every time I got wrong also. So it's a waste of resources. I have to compile it. Yes. .c. Run this out. See, it can run infinitely now. If I put an 8, I get it. Chururu. But the game does not like it because I did not put a limit on the number of tries. This limit is, it declares that something called tries exists. Oh, it's already declared up here. And every time the loop runs, there is this statement which increments, puts one more. And if I make several mistakes, you just leave the loop anyway. The while and the program. While loop. For the last loop, we held your hand. So let's try one on your own. As an example of iteration, we have the first program ever to run on a stalled program computer, the task. It was written and run by David Wheeler in the computer laboratory at Cambridge University, England, on May 6, 1948, to calculate and print a simple list of squares like the following. The most powerful tool ever. Let's calculate some squares with it. On the left, there are numbers from 0 to 9. On the right are the squares. For example, for the number 9. 9 times 9 equals 81. Note, an algorithm like this is one of the easiest tells for needing a loop. But as you develop your programming skills, you will pick up more and more subtle, how do you say that name again? Subtle. Transform the B and T into a D. Subtle hints and uses for where loops can be incorporated into your code. Write a while loop that prints out a number followed by a tab. Then the square of that number followed by a new line, like so. You want me to do exactly like this bullshit? It looks horrid. What the fuck is happening here? Number, variable, which links to the number, tab command, second variable, which is the root, the new line command. Have the while loop calculate these from 0 to 9. If you notice the run button spinning continuously, or a lost connection to Codecademy message in this exercise, you may have an infinite loop. If the stop condition for a loop is never met, we will create a loop that never exits, which prevents the program from ever completing. In this exercise, you can simply refresh the page to stop the infinite loop, then fix the code for your loop. However, we will talk more about infinite loops later, and even how to use them effectively. If you run one in a computer on an actual program, it will crash your RAM and close the program by critical failure of the hardware. Want me to write a loop? What? That would be a for loop? Why the hell would I use a while loop for this shit? While what? While why? Run it while y is greater than me. Increment y every time I. Just print this shit out. Exactly like it's written there. The tab for another int. Crazy shit. You don't need to differentiate your variables. Print this horrid shit. God. This squared. Print y is print I, that is I, put a tab on, and then print the next variable, that is I times I, and the line. Increment y, run it all again while I is less than 10, so 9. Once it gets to 10, it will be equal to 10 and it will not run again. It will run from 0, which is the original, to 10. is. But all the space to 20. Sure. Now change your while loop to go backwards from 9 and stop at 0. Your new output should look like this. I have to change my while in such a way that it will run backwards. I will not change my freaking while, I just change my freaking while. Chururupai. Why this shit is greater or equal to 0 decremented. So I do the same thing, but instead of starting at 0 and going to 10 incrementing it, I start at 9, went to 0 decrementing it. Do while loop, that's the one I used. Now that we have written our loop, let's write an alternate form of it. You look at its syntax first, then explain what's happening and why. Do why. This odd, the condition came after the statement. Does this mean the condition isn't checked until after the statement gets executed? That's exactly what happens. This is what's known as a do-while loop. Simply put, it does something first and then checks the condition afterward and loops in this manner until the condition is no longer true. The do-while loop is most often used when a program wants to do something at least once before checking the conditions. Convert the while loop into a do-while loop. While I less than 10, run this shit telling me y, telling me I, and incrementing it. So, do it while. You may have noticed there wasn't a difference between the outputs in this particular while loop and the do while loop. To see exactly how they run different, change int 0 to, because it would never run before at 11 or even at 10, but now it will run once. Oh, this is the big boy, the boss, the god. It runs things an exact number of times. The while loop examples we have looked at so far iterate over a sequence of numbers. It is so common that C, like most other programming languages, has a special syntax for it. When we know exactly how many times we want to iterate or count, we can use a for loop instead of a while loop. For example, this is a for loop. For int e I equals 0, I, while I is less than 10, increment I, and print I. Let's take a closer look at the first line. That's what say, the class the I exists, puts this conditional, and increment it at every run, while this condition is true. The three parts to this is separated by two statement markers semicolon. The initialization of a counter. int I 0. The condition I less than 10. The change in the counter, in this case an increment. In the first part, we create a variable I that starts from 0 and acts as our counter. In the second part, as long as our counter I is less than 10, the statements within the loop will repeatedly run. In the third and final part, after each iteration of the for loop, we add 1 to I using the plus plus operator. Or, in other words, we start with some initialized variable, then while some condition is true, we do something, and we incrementally change the control variable. Does this sound familiar? It's just like a while loop. In fact, the above for loop does the exact same as the while loop we just worked with the previous exercise. The while loop from exercise 5. It's a little of a chunkier boy than this beautiful slim thing. They can put on a single line. Notice I put things on a single line instead. They do not even need to use the keys. They need to follow this exactly. How you do it like that. This distinction is important because it allows us to switch between while loops and for loops to best fit the current program's need. If we don't quite know when a loop may end, we use a while loop. If we do know exactly when a loop should end, we use a for loop. Like running through your inventory. First, let's start with what you already know. Write a while loop that starts at 99, stops at 0, and prints the following. I bottles of pop on the wall. Take one down and pass it around. I -1 bottles of pop on the wall. It should then decrement I by 1. If you run into an infinite loop, refresh to page to stop it. The page. So while I is greater than 0, it will stop at 0. It will not count the 0 on the wall. It prints the following. It should print it all, or it should print the first part and pick in the next loop. I'm unsure. Bottles of pop on the wall. Take one down and pass it around. The other thing, it is a closing of the statement. Yeah, they did not mean to write the 3 lines, only 2. Next line comes the next part. Is it broken? Right now. Okay. Convert your while loop into a for loop. So just comment this out and run the for loop here. For each equals 0. 2 minus. You go the other way around now. Fuck me. Was greater than 0. 2 do not put on anything on this thing. Oh, I need 2 lines, man. Fuck me there. I do not need 2 lines. a single freaking statement. That's the same thing. Except I missed a dot, a space here, but yeah, here it is. It's kind of ugly because there is a single thing, but you do not need to put the actual keys around it. If you just write the dry statement like this, you can string it all as a single thing. It's very good when you want a simple equation or something to run instead of taking a bunch of space. Breaking out. When working with loops, it's important to know a few special keywords that can affect how a loop runs. Let's look at a quick example to introduce the first special keyword. You remember the while loop from exercise 3. The loop runs until A is guessed or 50 attempts have been made to guess the secret number. This means the loop will stop running as soon as one of those conditions is met. There is another way to write this, but using a special keyword. See if you can spot it. Here's the while, scan it. The keyword break allows us to quite literally break out of a loop and stop it from running any more times. It can often simply be avoided with careful planning of the conditional controlling a loop. It's generally advisable to be careful with breaking out of loops because it can result in unexpected processing when a program has a mental plan centered around a loop finishing all its iterations. However, when used effectively, a break can increase the efficiency of a program and help minimize its memory usage through unnecessary variables. Break is most often used when a program wants to run a loop infinitely in a controlled manner. For example, a program that runs until the user types quit, like a game. In that instance, the program may run forever, but will only break out of its running loop when the user tells it. In a program, the while loop will run a set amount of times or until a non-positive number is entered. This includes zero and negative numbers. Without changing the condition of the while loop, the right to get it should stop when a non-positive number is entered using the break rule. Numbers entered. If the motherfucking numbers entered, if the number 1 is less than 1, break. Number 1 is less or equal to 0. Why would I put less or equal to 0? Are you joking with my face? Number 1 less or equal to 0. It's stupid as fuck. Less than 1 is the correct expression. Instead of using two symbols, you can use a simple one. Less or equal to 0 is everything less than 1. You may have noticed the break keyword is necessary here to stop the loop from running. Create a second while loop below the first one and use the condition. Then, write the loop as normal without any break. Don't forget to initialize the new variables at the top of main. Run the program again with the second loop. You will see both loops act the same exact way and stop when a negative number is entered. A while loop has a condition number true is greater than 0. And numbers entered 2 is less than 10. and you run this thing with number 2, call it number 2, increase the number entered, the thrice, and initialize these things up here. Right before this thing, number 2, numbers entered 2. That's it. Have anything here that should test here, but I'm not going to test. There is a scan, you can try, you can play with it, but it works. It's meant to be. Should I try this? Infinity.c put a.out. What? I can keep putting numbers in here until it comes out. It will break out. I've broken out. And on the other one, I can put numbers. It will break out. It will just break out of the condition. Condition will be no longer true. It will not be a real break. Continuing. In a video game, a game over screen often allows you to continue from a previous save or checkpoint. Loops can do this in much the same way using continue. The second keyword we will learn this lesson. In a loop, if a continue is ever reached, it will immediately skip the rest of the statement inside the loop body and continue to the next iteration. For example, let's look at the following syntax. For this thing continue, print out. Inside the for loop, we see an if statement. This. Checking if the current counter I modulo 2 is even, equals 0. So does 2 fit in it? That means it's 0, or is there something left? If there is something left, it's not 0, and thus it's not even, it's odd. If it is even, it will run this conditional and then continue. So it will skip this iteration, the for loop will end this iteration and go to the next iteration. And if it is odd, as it will be the next iteration, you print, it will not enter this, it will continue to the end and begin the next one after it ends normally. So it prematurely ends the current counting of an iteration. The counting is not the right word, but it skips the rest of the iteration. These keywords can still affect a loop, even if they are contained inside an if statement. This means a continue will always advance to the next iteration, even if it's nested in multiple if-else statements. This goes for other loop keywords as well, like break. If there are nested loops, a keyword will only interact with the most interior loop it is contained. Use continue to make the while loop skip the print statement for when e equals 5, I equals 5. So, if e equals 5, continue. Except that I made an infinity loop here. Just mess that up. Oh, there is a while minus 10. So it's not an infinite loop. Should be work. Condition does not allow for an infinity loop. Why is it not working, man? It is 0, it's less than 10, so it will run. It will run if it is exactly 10. It will run the 9, it need to be 10, and it will no longer run, and it will end the code. It. This is all this has. Did you continue with this 5? Not print the 5. But it's having some problem with my shorthand here. Let me write this its entirety. Just like the for loop, you do not need to use the keys. You can just do that. Just did. It's much cooler. This shit is broken. It's continue infinitely. That's what I did. Break me. Because I is incremented down here. Motherfucker did this. And so it skips at 5 and goes to the next loop. But for the next loop it is still 5 because it has not incremented. So it's continue, skip, continue, infinity. Oh fuck, I put it below, I have to put it above. To increment before I skip the loop. And that's how you get. No, that's not how you get bugs in code. In a code. Because the code not run at all. Yeah. Before and 6, it skips it. Incrementing beforehand. So it increments to 6 and it skips. So it runs at 6 now and no longer falls within it. We skip before incrementing, it will be 5 again, the next loop, fall in, skip, with 5, fall in, skip, with 5, fall in, skip, and loop like that. Convert the while loop to a for loop. This way you don't have to worry about whether or not your counter will increment as normal when a continue is called. A for loop. A for loop will naturally increment the counter for you after any given iteration is completed. That is why it was catching me, because you do not use while loops to do these things. Int u equals to 0, u 110, u plus plus. If u equals 5, continue. And then the print. Print y on the next line. I. And that is u. U. Review. Great job! You completed the lesson on loops. Key concept discovered in this lesson. Loops perform repetitive actions, so we don't have to code those actions manually every time. How to write while loops with a condition. how to write do while loops with a condition, how to write for loops with a counter that increments or decrements, how to break out of a loop, how to continue a loop at any point. Run that loop. Man, there's a learning and there is a count integers. There's a while, learning plus plus, minus 10. Congratulations. Are you ready to continue learning in the next lesson? Print yes or no, scan my answer, and put that linkage to the same memory slot as count. If the memory slot that count is, that variable count equals 1, awesome. Let's break out and move forward. That's okay, keep practicing, and remember to take breaks. It does nothing else. So I put 2 or any other number, it will hit the else. I did not discriminate, just like I was doing on that yes or no question. That's how I evade breakers, because the user cannot use that shit. The user is the dumbest person you deal with on your endeavor as a programmer. And so, you have to avoid them breaking the code. That's why I do not make this equal 1 and equal 2. Because then the user will fucking press a 3 and break your fucking code. They told me to run put a.out. Like they'll put a 3 like this and break the code. But as he made the way through, no matter what he puts, it will run normally. Errors in C. Errors are simply unavoidable when you develop a program. Let's learn more about them. Learning to code can be frustrating endeavor because you are destined to encounter many red errors along the way. What makes a programmer successful isn't avoiding errors. No programmer can avoid them. Great programmers understand that errors are part of the process, and they know how to find the solution to each while learning something new from them. In this article, we will teach you how to think about errors in your code a little differently. There are many ways of classifying errors. For example, compile times error. Errors found by the compiler. You can further classify compile time errors based on which language rules they violate. For example, syntax errors and semantic errors. Syntax errors is when I mess that thing. I do not put the semicolon at the end. I do not put a parenthesis where it has to be one. So the syntax is wrong. A semantic one is when I actually write something wrong. Like that time I was going to write a word and wrote old. That way, the code would work if that thing existed, if a variable named odd existed. But since I put a variable that does not exist, the code is right, but it's semantically wrong because it does not exist, even though the logic and everything should be right, even the code variables exist. Link time errors. Errors found by the linker when it's trying to combine objective files into an executable program. Runtime errors. Errors found by checks in a running program. Tricking users. Logic errors. Errors found by the programmer looking for the causes of erroneous results. This is when the thing runs, the program runs, but does not run as you expected it to. It runs as it should naturally, just physics. But you expected it to output a 5 or 3 plus 2, but it outputs a 60 P7. and so you have to look for it, and the problem is you made something wrong. As you recall, the programming process looked like it. Code, debug, save, compile. The errors above are described as follows. Compile time error. When you are writing C programs, your compile is your first line of defense against errors. Here are the two types of compile errors: syntax errors. These errors occur when an invalid statement is written. Here, missed this. I missed the parentheses. These are the exact mentions I did, man. A parentheses and this thing. Because they are really, really common. Oh, it's missing a type here. Missing a semicolon and missing a written wrongly the type. It's on uppercase. In that case, this should be semantic, but it's on the case of syntax because it's part of the keywords. These statements are syntactically valid, but don't do what the programmer intends. Plus b equals c. I equals 1 times 2. Error. Use of an uninitialized variable. Using any uninitialized variable. We put it on the wrong side. Here, 1 I equals I plus 2. Error. Use of an uninitialized variable. We initialize this fucking shit right up here, man. What is happening? Link time errors or linker errors. If your program has no compile time errors, these link time errors will occur when an attempt is made to actually compile. These appear when a program is missing proper prototypes, has incorrect header files, or accidentally uses main instead of main. Runtime errors. If your program has no compile time errors and no link time errors, it will run. Runtime errors appear during its first. Can manifest in a handful of unique ways. One most common way being a division error when divided by 0. These types of errors can be difficult to find due to them being syntactically right and missed by the compiler. The user when he input a 0 on the freak division. Logic errors. Once you have removed the initial compile time errors, link time errors, and runtime errors, the program finally runs without hiccups. However, sometimes the output is produced or the output the program produces is just wrong. This can occur for a number of reasons. Maybe your understanding of the underlying program is flawed. Maybe you didn't write what you thought you wrote, or certain lines executed in unexpected ways. These are logic errors, aptly named after errors that could arise in a coder's logic inside the program. That's all of them. Avoiding errors may sometimes feel impossible, but learning from them and understanding the different types can all be as part of the coding process as the coding itself. Coding. So remember what errors mean, how they appear, how to solve them, and keep programming. Errors in C. That's the article. There's some quiz and quiz. And now it's arrays. I have used one, but they're going to teach them now. A few lessons. There's 2.5 in the morning. Here we go. Introduction to arrays. An array is a grouping of variables of the same type into contiguous blocks of memory. This data structure is especially useful in applications when there are many variables of the same type that are related to each other. Consider the example of having to store the 3 coordinates of a point in space, coordinate x, y, and z. Valid way you can store these coordinates in variables is with separate variables. While this is okay, especially for a small number of coordinates, it will become harder to manage as the number of coordinates increases. A solution to this problem is to store the coordinates in a data structure called an array. So this is an array that takes 3 coordinates and you can put where your character is at all times in a three-dimensional environment. Time would require any coordinate though, but as he'd explained, when you have several data types, like the gravity of several different planets, instead of declaring gravity for each planet has several variables, you can just make an array. That is what I did. I made an array of gravities and listed in the order of the planet's number. And so just by passing the planet number, you could recover its gravity and made the code a single function call for all of them instead of editing, hard coding the exact variable for each planet gravity. This piece of code declares a variable of type array called coordinates. Since the three coordinates are related to each other and are likely to be used together frequently, the coordinates array neatly extends them into one variable. We will explore how to access and manipulate the elements of an array in future exercises. Under the hood, the coordinates variable creates three empty variables in memory, which are stored contiguously. As a visual representation, you may think of an array as a group of lockers, not unlike those found in a gym, where each locker is responsible for storing one variable of type int, or any other variable type you have learned so far. Creating and initializing arrays. An array is a collection of data that can be of any type. For example, you can construct an array of ints, bool, characters, etc. They have never taught a bool before me. But a bool is a boolean. They have used that word before. Like when you put an if greater than 3. Do something, you can instead create a bool called nums and equal that bool to 4 greater than 3. If this is true or not, or what it is, yeah, I evaluate it by this bool, and you can just pass nums here. Why is this thing red? But anyway, this is what a bool is. It stores true or false, one of the two. Can be linked to expressions. There are two types of arrays that can be created, an initialized array or an initialized array. I used this later on. No, I actually initialized it, but I made an implicit one. I did not specify how many elements it had. Its name implies an initialized array is created without specifying the initial value it contains. As an example, we will create an initialized array called age. Contain 4 variables of type int, which represent the age of 4 sims. So it just declared here. Did not assign the value. This thing is colored like that because this is an older lesson or something, and they use a different style of color coding, which is wrong and sucks. But yeah, let's go on. Initialize it, they just declare it without declaring the number, without assigning a value. To indicate to the compiler that age is an array of int and not a single int variable, we append array size. In this case, array size is 4 to the end of the variable name. The general template for creating an initialized array is data type name array size. As you can see, even the style they are telling things is different. On the other, they use type variable name. This must be older, lower level. When you create an initialized array, You are required to specify its size so that the compiler may reserve the proper amount of memory blocks. You are required. No, I'm not. I just initialized one without it. So that the compiler preserve the proper amount of blocks. Ah, when you create an uninitialized, mine was initialized, so it was implicit. Once it is created, the size of the array cannot be changed. This means that the arrays are static in C. This is the case for C. An uninitialized array can be populated later in a program. In contrast, an initialized array is created by specifying the initial value of its elements. As an example, we will create an age array with 4 initial ages. So it does not need to put the thing here because it's implicit here. The general template for creating an initialized array is like this. Notice that in this case, you don't need to specify the size of the array as it is implied from the number of elements supplied. However, declaring an initialized array with the size specified will also work. The previous example could have also been written like this. Create an uninitialized array with 5 doubles called Q. Double Q 5. Create an initialized array of integers called events consisting of the first 5 even numbers starting with 2. Double. It's an integer. It's called events. It's implicit. Does nothing that is not to run. Just judges if I made it right or not. Array access and element modification. Array elements can be accessed, modified, and used just like any other variable of the same type of data. The same data type. The following shows how to access an element in an array at index. You could see that I used the number of the planet as the array indexed. That way, as I put them in order, I could reference to the data, to the gravity, by using the planet of the number, which was the same being used on a switch. So by putting the array and the number, you'll find the one I want. The first element in an array has index 0, and as the last element in an array has index array size -1. The nth element is at index n -1. So for example, the third element would be at index 2. You could see that I put the first value of that planet gravity array as 0, because 1 was the first planet at Mercury that needed to have Mercury at 1. So I filled with 0 the 0th element. An element in an array is modified just like a regular variable. Array, the index number, and the value you want to change. You assign it the same way with an equal sign. Remember to be consistent with the data types. For example, elements of an array of integers can only be modified to represent other integer values. Anything else will cause errors. When working with arrays, it is important to be careful and not attempt to access an element at an index greater than array size -1, as the memory located there could be storing other data. Accessing an array at an index greater than array -1 will return a random value. A random value? Do not crash this shit. It usually means a crash. But since C is a very low level. It's dealing very close to the computer language, actually manipulating the locations in memory. I suppose it can access things like that. The pointers. Modifying an element at an index greater than array size -1 will corrupt the data stored at that location, causing the program to behave in an unpredictable manner. The same is true for array access at indexes less than 0. Baroque. Let me say this is a baroque. Because of the pointers, I can point at anywhere I want in memory. I can fuck up anywhere of the memory. Really cool. The following piece of code changes an element in an array and assigns it to a lone variable. There's the int main. I declare an int called r. It's an array, has 4 elements, and our element number 2, which is 7, I modify it to 6. And I make a variable called x. It's an integer. I equal it to the third element of the array. It is array index number 2, which is now 6, which was 7 before. And it will print that thing. That is 6 now. The accompanying code erroneously attempts to print the last value in the events array. Fix this bug. So it is trying to print the last element here. 1, 2, 3, 4, 5, 6. And it's broken because 6, index 6 does not exist. This is 0, 1, 2, 3, 4, 5. So it's telling me to put a 5 in here. These instructions are much less clear. They actually hold your hand much less. That can get annoying, but there is hints. So these are actually better at teaching you to do shit. Print the third element of the events array. The odds array even is intended to contain the first 6 odd numbers. Notice that some values are incorrect. Fix them by changing their values to the correct odd numbers. Do this by using array access. I write this here like this? Problem though. So fix this events. These odds. So do not modify this line. Do not modify it and instead use this. Five, 7. Yeah, 9. Okay. I reference the first index 1, which is here, 0, 1, and the index 4 is here, and change them the correct odd numbers. Looping through arrays. The main benefit of arrays is the ability to work with large amount of data without assigning each piece of data its own variable name. Therefore, arrays usually contain many elements. To work with these elements, you will probably have to do something repeatedly. As you learned earlier in the course, a loop is used in order to execute repeated code. The technique of using a loop on an array is called looping through the array. Recall the two kinds of loops, a for loop and a while loop. Let's first take a look at how to loop through an array using a while loop. Consider the example of having an array consisting of 20 random integers and you wish to print its contents to the screen. Here's how this is done with a while loop. Main declares the array, declares the int, while the int is less than 20, print that shit out. Access elements at the index of e and prints it, and increments e, run again till it's 20. In this piece of code, we have 20 integers array here. An index variable here is declared and initialized outside of the loop. The loop runs for indices less than the size of the array, 20. The element at index e is printed along with a new line. Finally, the index is incremented by 1. This same process can be done using a for loop like so. Array declare for loop while less than 20, increment it, and print that thing, the current e. The value at the index of the current e. Loop to array R and print each element on a separate line. The array contains 20 elements. F. What do? Print the element on each line. To print an element, I have to do this shit and link that to the variable I want, which is the variable of R at the index of I. Some shitty crashes. Exercise 4. Function in 8, 42. Where's the 42? There is no information of my location. I was not declared. Oh, it's a null. It's wrong because I did not put the new line there. Even then, integer array array2 fill up the array so that each element in the array is 4 plus the index element. Fill up the array with a loop, crazy shit. So for loop int equals 0, d less than 100, d plus plus, r at d equals d plus 4. So if you loop from 0 to 100, increasing at every loop, that's how breaking loops work. And at every loop, what it will do is access the array at the index of this loop. So at the index 0, it will be 0 plus 4. At index 1, it will assign it 1 plus 4 all the way. Yes, it has. What are you saying, motherfucker? Unexpected and qualified equals. Oh, that's R. I'm trying to access R. It's R2. It's crashing the same way. Chururu. Unqualified ID field before 4. Oh, I put it outside the main thing. And it's not writing them out because just write from 4 to 104 to 99 plus 4 to 103. You want to see it? Want to see that you need to add the key, print the sheet at R2 index, at the index of the number of the loop. Let me put an if. If R2, if R2 at the index modulo 40 equals 0, then f a line break. So if you break the line at every 10 numbers, if I put this, where is it? How do I end this face? Yeah, every 10 numbers it breaks the line. These look bigger because, well, they are bigger. One single digit, and these are 2-digit. But at every 10 number, the modulo returns 0. Because at 14 it returns 0. At 28 times 2 it returns 0. You can see here the multiples. And then it ends. But you can see it printed everything, and everything is 4 times greater than the number of the array. 0 it is 4, and at 99, 103. Length of array using size of. So the array can call functions to get its size and other properties. Up to now, when looping through an array, the size of the array has been hard-coded into the loop condition. This is bad practice, as it makes the loop only applicable to arrays of a single size. To make a loop valid for arrays of any size, the size of function is used. Size of is a special function that returns an integer that is the size of the array in bytes. The syntax for this function is as follows. Call the function and pass the freaking array in. That's it. That equals an integer. Int main declares an array, int length, and that length will be equal to the integer returned by the function of size of that array passed. If you print that, it will print the length of that thing. Is 5. The array has 5 elements in it. However, this code will output the number 20 as opposed to 5 because size of returns the total number of bytes occupied by the array regardless of the type of elements. Wait, it's the size of, it's not length of, size. Recall that a variable occupies several bytes in memory determined by its type. In this case, the array has 5 integers, each of which occupy 4 bytes of memory. Therefore, the total size is 5 times 4, 20 bytes. To get the actual number of elements in the array, we have to divide the total size of the array by the size of the data type it contains. Fortunately, the size of function can also be applied any type to determine its size in memory. The syntax is the same as that for an array, size of data type. So you do not have the length of array property. You have to call the size by bytes and solve it out yourself. We can modify the variable length to represent the number of elements in the array are, like so. By getting the size of the array, you can divide that by the size of an integer. Then I have to learn the size of the integer and hard coding it. The code will now output the expected size of the array, 5. Using this technique, a loop can now be written to work with arrays of arbitrary length. Here's an example. The main function. Declare the array, make the length to be the size divided by the size of its type, and then run a loop less than the length of it. That's it. Print it out. Notice how in the condition for the for loop, the variable length is used to represent the length of the array as opposed to hard coding it in. We can further simplify the code above by eliminating the variable length and directly computing the size of the array in the loop condition. So you put the equation on the condition. Set the variable length to the length of the array R. So len equals size of R. R is a double, but the size of is a stupid integer. Did you remember to use the size of function for both R and double? So I'm meant to put the length of things, not the size. I have to divide it already. Equation straight out. Loop through the array and print the contents. Each element should be on a new line. Loop through the array and print the contents. What the fuck, man? Why is this thing uppercase? No matter what I do, it's uppercase. Freaking me. Okay then, motherfucker. Uppercase. For int equals to, no, int equals to 0 to minus then the length plus plus. Then print f. Loop through the array and print the contents. This thing. The double. Which is just a on a new line. Floating points of the array. Cool. Multi-dimensional arrays. A matrix. As we said before, arrays can contain any kind of data type, be it int, char, or anything else. Interesting, arrays can also store other arrays. An array containing other arrays is known as a multidimensional array. These kind of arrays are frequently used in mathematical applications that invoke matrices and vectors. Similar to its single-dimensional counterparts, a multidimensional array can be initialized or uninitialized upon its creation. Let's take a look at the uninitialized version first. The following is a two-dimensional array of integers called math, which represents a 3 by 4 matrix. Arrays like these are much used on artificial intelligence. It's the core of it, because it links the neurons and other parts it has to do with. So you make an array, but not like this really. It's actually an array of arrays. It has an array inside of it. Its elements are arrays. The previous code indicates that the array math contains 3 elements each, of which is an array that contains 4 integers. Like this. An array of array. To visualize this, consider a row of 3 lockers, in which each locker contains 4 sub-lockers that someone can store items in. To illustrate how to create an initialized multidimensional array, we will create a 2 by 3 dimensional array called maths2, composed of random integer values. We have an array. The array has 2 elements, this array and this array. You access this array at 0 and this array at 1. 0, 2 is 3, 0, 1 is 6, 1, 0 is 5, 1, 1 is 9. And there's a comma there. Just like in the single dimensional case, the array is initialized by placing elements between brackets. On artificial intelligence, you put every other array on the others and tweak the connections like that. The strength of it by iteration and backpropagation. Okay. In this case, the elements inside the outermost brackets are arrays of 3 elements each. It is important to note that while the 2 by 3 dimension can be inferred from the right hand side of the expression, the only dimension that can be omitted is the first. Notice the first is empty. All other must be supplied. The array math2 represents this table, because this one is implicit. The others has to all agree with each other, so it cannot vary implicitly like that. While it is possible to have a theoretically infinite number of dimensions, in practice dimensions greater than 2 are very rare. For a two-dimensional matrix, the first dimensions represent the number of rows and the second dimension represents the number of columns. Create a two-dimensional 9 by 9 uninitialized array of integers called R. Integer R 9 by 9. Given the following table, create an initialized two-dimensional array called matrix that represents it. So this is the matrix. It's an int. Yes, it's an int. Matrix. I should initialize this thing. Two-dimensional? Why does it look like 3D? And it's like this. What's a row? What's a column? So, as you can see, it's 3 by 3 dimensional matrix. So I have an array. That's my initial array here. An array of 3. I do not need to specify. I can. This array has 3 elements. This is one element. This is another element. And this is another element. And it just happened. This element, instead of being an A, a B, and a C, are each of them an array. Array A, array B, and array C. This array E is of size 3. All of them are of the same size, but each contain their own elements. And that's a matrix, a two-dimensional array like that. Normal array, and its elements are arrays. Okay. That's all there is to it. But when you start to using it, it becomes more complex. To do some complex equations with it. Does not do, does it? The equation cross that shit out. And all of that. Elements in a multiple dimensional array are accessed in like so. Array row number, column number. Similar to the single dimensional counterparts, the first row is at index 0. So this is the 0th array. And the last row is at index first dimension minus 1. This is the same for the columns too. Consider this example of a 3 by 3 matrix of integers. So there are 3 elements, there are 3 arrays, and each of them have 3 integers inside. To access the elements on the second row and third column, we put 1 and 2. But 1 is this one. Because this is 0, this is 1. And then 2. 0, 1, 2. It's 17. It was 2, 2. Then it was 0, 1, 2. That's the one. And 0, 1, 2. That's 10. Looping through a multidimensional array is similar to looping through a single-dimensional array with a slight difference that having multiple dimensions will require nested loops. While you can use nested while loops, it is better for a nested for loop. In the two-dimensional case, the outer loop goes through the rows and the inner loops go through the columns. To prevent the hard coding of dimensions in a loop, the size of a function is used as follows. Row dimensions. Size of matrix. Size of matrix 0. Column dimensions. Size of matrix 0. Size data type. Let's use these identities to write for the for loop from the previous exercise. So we have a 3 by 3 matrix and we declare it, and then we declare the dimension of rows by dividing it by the size of whatever the fuck that array is. We usually divide by the type like this, int or a double or what it is. But as we do not have a type, or type is freaking array itself, an array of trees is all type, we just divide that by the space that an array of 3 occupies. And so we run for the length, how long we wish to run, we pass that in, that length we got from these equations. Two loops. And the accompanying code block write code that prints the element that is the fourth row and second column of the matrix. So the first one, I want to print some shit. Print shit and an integer. It's an integer in the matrix. I want one that is the fourth row. The fourth is the third, obviously, but it starts at 0. And the second column is the number 1. That's it. So the fourth, 1, 2, 3, 4. After the third, because 0, 1, 2, 3. And 1 is the second. 0, 1. So loop through matrix and add up all the elements. Assign your answer to the sum variable. It's crazier than before. So for loop, we will loop through it by a sign or counter by making our counter less than the size of the matrix. Let's use the function size of call the matrix, and that size of the total matrix is divided by the divided here by the size of its element, which is any element it has. And then we increment our counter. Inside of that, we make a new loop, which I call unus, duo, trios. But the normal one is this ing. Then an L, I think. Okay. Okay, then an L. Okay. U. Now it's a D. Less than the size of the matrix, any element, divided by the size of its actual type, which is int. And what the game wants me to do with this is to print f the sum. Print sum. To print the sum. Oh, you don't tell me to print. It told me to put in the sum. Sum equals what mean? The sum of all elements in the matrix. So what do I do? Plus matrix at u and at v. Let me check this. The sum, and I'm adding the matrix at u. So u is 0. 0 will get d0. So 0, 1. And then it will loop again by 0, 2, 0, 3. That's it. And as it hits the 0, 3, it ends this loop. It actually comes out. And then will be 1. Then will be 1, 0, 1, 1, 1, 2, 1, 3. And you sum all of these at sum. Yes. Right. Then I will print that thing because I want to see it. There's some nested shit here. I can put it all in a single line, but I'll leave it like that. Something went wrong. I forgot something somewhere. I forgot the stupid counter in here. That's the number. It's a freaking huge number. That's not possible. All of these gave this number. It is wrong. Print this number. 0 times 10 times 6 times 4 times 3 times 7 times 18 times 11 times this gives this number. It is not right. Oh, this stupid shit here that's messing with me. 151. Review. Good job! You have just completed the lesson on arrays, probably the most used data structure in software development. Here is a quick recap of everything. Arrays are a special type of data, a special data type that allows you to group together many variables that are related. An array of 100 elements saves you the trouble of having to create 100 variables in your code. Saves the trouble of creating 99 variables, because I have to create the array, which is a variable. Arrays can be of any data type, be it primitive, custom-made, or even other arrays. that is, I just started multidimensional arrays, that is that other arrays. Primitives are like int, because that's primitive. They do not dot strings, but string is a kind of array of characters, so it's more advanced. And custom made are usually called objects. Arrays are immutable, so the number of elements must be known at creation time in order for the programmer to know how much memory to reserve. After creation, elements may not be added or deleted from the array. Upon creation, an array can be initialized or uninitialized. A single dimension uninitialized array is created like this. A single dimension initialized array is created like this. In the initialized case, the size of the array is inferred from the number of elements that are supplied. All elements of an array occupy contiguous location in memory. An element in an array can be accessed like so. The first element in an array is always at index 0. The last element is at index array length minus 1. The end element is at index n minus 1. Elements in an array can be modified like this. Since arrays usually contain many elements, the most efficient way to work with them is by using a loop, for loop or while loop. Multidimensional arrays are simple arrays of arrays, are simply arrays of arrays. They are created, accessed, and modified in the same way as their single-dimensional counterpart. At this point, you should be comfortable working with arrays when you need to. Use them wisely. Introductions to string. The very first exercise in this course was the traditional task of printing a line "Hello World" to the screen. In this lesson, we will dive deeper into the data type of "Hello World" and explore its property and functions. In C, the line "Hello World" is known as a string, as it is simply a string of characters. Strings are very important in programming and software engineering, as they allow the program to display output to the user and can even be used to debug errors. In the C programming language, a string is represented by an array of char and is consequently subject to all the properties and methods associated with arrays. The most common function used with the string is the printf function, as you have seen before. The god of debugging. Creating and initializing strings. Creating a string can be done in one of two ways. The first way is to simply create an initialized array of characters populated by the characters of the string. This is an example of the string "Hello World" created using an initialized array. The characters array is populated by the characters of "Hello World". There are two important things to note here. A blank space is a character, so it is included by putting a space in single quotes. The very last character in the array is /0, known as the null terminating character. It signifies the end of the string. It must be included when creating a string as an initialized array. The string "Hello World" has 11 characters in it. The space is a character too. Saying that again. But the size of the string is 12, 11 characters for "Hello World" plus 1 for the null character. The second way to create a string variable in C is to use what is called a string literal. This is the creation of a string by initializing the char array with a full string in double quotes like so. Char array, double quotes. It is still an array of characters and is to be treated as such. The only benefit to creating a string in this way is that it's easier to type and the new terminating character is added implicitly. The size of this array is still 12 for the same reasons mentioned before. Using the printf function to print the string is done by providing the name of the string array, regardless of how it was created, and $s to signify that print_s is working with a string. This is an example. Print the string. It's like any variable, you do not just put it in. That's very, very primitive, making me sad to look at this. Characters in C are case sensitive, yes. Characters A and A are treated as two different kinds of character. Create the string computer using an initialized array of chars. The variable should be called comp. String variable. Initialized array. That's the bad one. The awful one. So the character, it's called comp, and it's an array. It's contained and compute. Using string literals, create a string called compicode. Contain the string compicode. Computer code. Look at the difference in production, man. It's absolute insane. Insanity. Print the string starting in comp followed by the string starting in comp on separate lines. There is a different linking cluster here. Always on the upper case. Do you see how much bigger it is? Look at this. It's still big. It's still big, what the fuck? It was bigger down there. Print it. I have to print both of them separated by a space. What do I call a string? A character? Something crashed. Compo does not exist. Something crashed again. Nothing. This one. Expect argument of type int. What's a character then? S? What the fuck? Character access and modifications. The characters of a string are accessed using the same method as those for a regular array. It is important to note that since strings are arrays of characters, they are subject to all the same constraints of an array. This means a string cannot be extended to add new characters, and a character in a string cannot be deleted. Recall from the lesson on arrays that an element is an array. In an array is accessed like so. It's so bad, man. That sucks so much. On normal programming languages, you can normally just alter the string naturally. And you declare it by calling a string keyword instead of an explicit array. Array and the index to find the numbers of the string. In the case of strings, the index represents the character at that index. And just like arrays, the name of the character is at index any minus 1. Here's an example. The code above creates the string hello world in both ways. String 6 and string 6 will access the characters at index 6, which is the 70th character in both strings respectively. In this case, this character is W, which is the same for both strings since they are identical. Modifying a character in a string is done in the same way as modifying an element in an array regardless of how the string was created. In the case of strings, new value represents the new character to be placed. Remember that it's not possible to add characters or delete them. Here's an example. Replace Y with W. Print the third character of the string. Print F with shit and P at 2. Just 2 is the third. Some da cá. Reflexive na int, velho. Vai tomar no meio do cu. Processa. Printed the entire thing. It's a new 9. It printed O, the third character. The processor was printed by the that function down here. The string P incorrectly attempts to spell the word processor. Correct this mistake. Zero, 1, 2, 3, 4, 5, and 6. 5. Looping through strings. Just like arrays, you can also loop through a string to access or modify its characters. You can use a while loop or a for loop, but in most cases a for loop is much more convenient. Here is an example of looping through a string. Get the thing and loop through it. No. This code you loop through the string hello world and print the characters to the screen. Note that in a loop you do not need to account for the null terminating character, as it is unlikely you will need to use it. However, there is a small problem with this code. The for loop hardly codes the length of the string 11 in this case, in the condition statement. Writing loops in such a way presents a problem as the length of the string is hardly known beforehand and makes this loop valid only for strings with 11 characters. To remedy this problem and make the loop valid for strings of any length, we can use the string length function. This function determines the length of the string. It is usually like so. It's more practical than array. Array cannot determine the length, you have to determine the size and divide it by the character type. The string length function is a special string function contained in the string library. To use it, the code must include the following line at the top of the file. Include a string library. String ag. The example code from above can now be written like this. Instead of hard coding, put a string length to this string. Note that the string length does not account for the null terminating character. The string s contains a message that must be concealed. Using loop, replace every character in the string with a character of this, an asterisk. So for loop int u equals 0, while u is less than the string length of s, s at u is equal asterisk. String p contains the string u loop, and its mirror string loop. Loop through the string and replace the first half with that thing. You can use it, it's not inside. u less than the string length of the. Now, I need some harder level logic now. I should not make that in a single line. To put an if statement and on the if call when u is less than only when pattern for that p be converted into the hashtag. Concatenating strings. Just like there exists a function for strings that return its length, string length, the string library contains all the useful string functions. In this exercise, we will explore how to concatenate two strings together using the string cat function. The string cat function takes one string and appends it to the end of other string. Using this function does not create a separated string, but modifies the DST string to include the string at the end. The syntax for this is string catch the string at the end. At first glance, it may appear that some magic has taken place here because it is known that the strings, because they are arrays, are immutable. What actually happens is the function takes the two strings and creates a char array of size string plus string length plus 1. It then populates the array with the character of both strings starting with ds. Finally, it discards the memory occupied by the original ds string and associates the ds string variable with the new character array created. This is all done for you under the hood, using the concept of pointers, a topic that will be discussed in a future lesson. So it does finally create a third string, but that lacks the other, which is the case always for the case when you are altering. And on the other languages, you just do it in less explicit. Have your things included, you have your main thing, you have two strings, you call that special function that is found in here, and it fuses them to a single thing by making this new thing and deleting the other. Concatenate string s1 and s2 and print the result. Include a new line at the end of the output. You can see they put a space in here, because if you fuse, there would be a single word. But now the space counts and you separate them. GG happens. 15. Printf. I have to call a variable and load that shit, I forgot. Did you remember to print the result? Make sure you include a new line. Concatenate the string New York. Print the result. String catch. I have to put that thing that is SS. This is for print. Crazy. Maybe I should go to sleep. I can put all of them with no worries. President dies. I have to concatenate this shit twice. Are you joking with me? Or is this how life is? Concatenate with an array composed of y and c. Nope. Two records of pathetic. Meu Deus, meu Deus. Let's see. I did something. Oh, put on a string. There. I have to use this thing twice because oh my god. Copying strings. In this exercise, we will take a look at the string copy function, which is used to copy a string into an empty character array. Empty string. The syntax for this function is this. Given a string source and an empty string empty character array, est, the string copy function copies the contents of the string into the dst string. It is important that the size of the empty character string dst be greater than or equal to the length of the string plus 1 for the new character, in order to accommodate all incoming characters. If the dst array is too short, the program will exhibit undefined behavior. Similar to the string cat function, a new string will not be created. The following example illustrates the use of string copy. Make a sheet that fits it, copy it, and it will copy. Me, fucking A. I cannot you put an equal. The two. Arrays can be equal. And this thing. But here you go. Copy the string CSD to DST. So string copy of from the opposite order, me. Mind you blown. Variable length represents the size of an empty character array that will be used to receive a copied string. Initially, it contains the number 0. Change the variable length so that the empty char array dst2 has enough space to store the letters of the string. Use the minimum amount of space, man. Do you really want me to count the shit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 9, 30, 31, 32, 33, 34, 36, 35, 36, 37, 38 for the other thing. I underestimated greatly the size. How many motherfucking letters has this shit? Tomar no meio do. How is that function called? this shit for me, will ya? Can you do that for me? Can you print this motherfucking piece of shit for me? I have to guess. What? The of coding. Dealing with the developer of this shit. Put this shit on a Twitter. They do not show how much space I have. Put this on a Word document and they tell me. Fuck. Ah, 36 fucking characters. Then it's 37. We don't know. Did you change the length? In space. Opa. That's why would they put such retarded exercise? I've put that 7, put that 6, and neither worked. What am I supposed to do with this piece of trash? To guess how many are there? I've counted it and it's 37. You don't know. What else do you want me to do? Do that with the string length and get your package. I'm not to tell you how to do this shit, but do it the way we want. Yes. Copy the letter of pan into DST. Not update right. That's 0. There's 36 and 37 with that. No. Banana over there. Review. Congratulations on completing the lesson on string in C. You are now capable of solving many problems that require string manipulation. Here's a brief review of everything you learned. In C, strings are simple arrays of char data type. Since strings are arrays, they are subject to other properties and constraints of an array. You cannot change the size of a string, you cannot delete characters from a string or replace them. Modifying a character in a string is done in the same way as modifying an element in an array. You can loop through a string like you would an array. A string can be created in one of two ways. The first being an array of char. The second and more convenient is to use a string literal. An empty string of length is created like so, character length line. All strings must end with a no-terminate character. This character must be added manually when creating a string using the array method. This character is automatically added when creating a string using a string literal. The length of a string is the number of characters it contains plus 1 to account for the null character. There exists a library in C language that contains common functions that are used to operate on strings. The library is imported by including the line include string ag at the top of the code. The strength function returns the number of characters in that string excluding the new terminator. The syntax is like this. The string concatenation function concatenates two strings together. That's the syntax, and string cat creates a new string of length string plus these other things containing all the characters of string DST and source. The new string is assigned to the variable holding the original DST string. A separated string is not created. The function string copy copies
an existing string into a new empty string. The empty string must be long enough to accommodate the original string, or else undefined behavior will occur. Good work. Skip for now. Pointers memory in C. This will be about the final lesson. Let's get this done with. Virtual address space. Physical address space. It shows here, that shows the physical space where it's stored. There's a circuit, just a bunch of switches turning on and off. That's the binary. And everything is stored there. The sum of the parts of something, the final result. Something is just the sum of its parts. Like this. There's no special space that goes down on the brain or on a computer to make it work. And so pointers direct exact where that piece of information is located, which is the part of it. A RAM has a specific megabytes or gigabytes, and exactly the number of spaces it has to hold each of those things. So you just number the freaking space it is in. For a program to execute it, must use some of the computer's resources, such as the CPU, RAM, or I/O, or other hardware. Deciding how and at what capacity to use these resources is the job of the underlying operating system. One of the most important of these resources is memory, more specifically the temporary memory used for program execution, which is called random access memory, RAM. When a program executes, the operating system reserves a section of the computer's physical RAM to be used exclusively by the program. The fundamental unit of this memory is a byte. As you learned previously, all variables are simply a collection of some number of bytes. An int is 4 bytes, a double is 8, and so on. The allocated section of RAM is simply a block of however many bytes the program needs, if available, of course. You can see in this block of memory to the right, every byte has an associated address numbered using the hexadecimal numbering system. For example, a byte of memory could be located on address 0 times 200, and the immediate byte next to it is located at address 0 times 201. Every programming language has a different policy regarding the direct access and manipulation of a byte in memory. Some allow it, some do not. C is one of the languages that allows such operations through the use of pointers, and we will see how in this lesson. At first glance, pointers may appear to be an overcomplicated way to work with variables, and for such simple examples meant to illustrate basic principles, this is true. However, the real value of pointers become apparent in more complex applications. such as working with data structures or embedded systems, think robots and microchips. Examples of these are well beyond the scope of this introductory tutorial. For now, just familiarize yourself with these ideas such that you may recall them when you need to. You can point several variables to the same data, and you change it. That pointer, the data thing, you change all of those variables together with it. So you link them, like that input thing that you call. In C, a byte of memory can be accessed using a pointer. A pointer containing the address of a variable is said to point to the variable. Objects in C# are pointing to the same addresses. So when you pass it to a function and messes with it inside the function, you actually change the object, the original object. Because it does not just copy everything, it uses the same pointer. And you can forcibly do so with other variables too, if when you are passing then you input explicitly that you want to do that. Recall that when you declare a variable, a contiguous block of bytes is reserved in memory. A pointer to a variable is the address of the first of these bytes. A pointer can be created for every type of variable, be it primitive, for example int, integer, character, or double. A custom data type created using a struct. We'll cover those in a later lesson. Will we? Or even another pointer. The syntax of a pointer is the following: data type times name of pointer, or data type times name of pointer. Wait. Asterisk changed position. For example, if you declare a pointer variable called ptr that points to an int, you would write int ptr or int ptr. In this case, ptr is the address of the first byte of a block of memory containing an int. To print this address to the screen, printf is used like so. Print the point. Int x equals the location of x pointers to that int. We will dive into what at means in the coming exercise. That's the thing that they were using on that answer to the console thing. This will output a hexadecimal integer that represents the address in memory that is storing a variable of type int. This number will be different every time the program is executed. If we had another pointer named ptr2 that does not point to a declarable variable, printing it results in new, rather than a hexadecimal address. In later exercise, we will see how to use pointers. Create a double variable named ptval. Create a pointer variable called dptboo that points to the bootdevu. Edge, auto edge. I like the edge here. DL, what the fuck is that? Double. EVL. EVL. Too far. Pointer variable. Oh, I forgot the asterisk. Print the address storing that thing. Pointer user p. That each. And that's the hexadecimal for that. this thing, what is it? Oh, it used 200. So yes, it's 201. But after 209, it's not 210. It's the things. The hexadecimals A, B, C, D. The reference operator. Since pointers are used to store the memory address of a variable, we need to obtain this address first. This is done by using the reference operator. The syntax for this is variable name. Consider the following piece of code. Int x equals 9. Printf of pointer of x. This will output to the screen the memory address of the variable x. To assign an address to a pointer, the following syntax is used. Pointer equals at that variable. Consider the following example. The code above declares an integer variable x here and an int pointer. The pointer is then assigned to the memory of the variable x at x here, at x. The last two print statements print this address. Both lines will output the same hexadecimal number as they both refer to the same address in memory. The address a pointer contains is not constant. A pointer may be reassigned to a new address so long as type consistency is maintained. Each pointer points to a variable type int. Consider this example. I make a pointer, I make x, I point at x, I print x, I make y, I point at y, and I print y. I can print point on both kinds, but in different places. Declare a pointer to a double called double PTR and double putain and assign to it the address of a variable g. Double pointer double putain equals to the address of a variable g at g. Print the address of that thing. How do I print it? The print as a g. That's easier than the pointer sheet. We assign that thing to the address of p. The reference operator. If we have a pointer that is assigned the memory address of a variable, eventually we will need to access the data that it contains, so we can use or manipulate it. The data contained in the memory address pointed to by a pointer can be accessed using the reference operator. The syntax is as follows. Drop the asterisk there and that's it. Once a pointer is dereferenced, we can use its content as we would a regular variable. It is important not to confuse this operator with the multiplicate operator, as they are represented by the same symbol. Here's a full example. You make x declared, you point something to x, and then you just make y equals to what is the value of that pointer. That's the value that that pointer is pointing to. What is the value that is stored in the box that the pointer is pointing to? The code above illustrates how to obtain the data stored in the address pointed to by PTR by dereferencing. Since PTR stores the address of a variable x, the value obtained by dereferencing PTR is the value of x. The value of a dereferenced pointer is changed, the value of the corresponding variable will change in the same way. And so x equals 200. Yeah. it links them together. The code above declares a variable x with an initial value of 4. The pointer PTA points to the memory address of x. PTA equals 200 changes the data at the memory address storing PTA to 200. Since this memory address is that of the variable x, the value of x now changes from 4 to 200. Because x is just a variable, just a pointer, fixed at that point. And all manipulation you do, you are changing the content of that point. A pointer is able to intentionally move the pointer itself and point at different places and change them. Like God moving around, teleporting to shit and doing what it will, changing orders. Print the data stored in the memory address that PTA is pointing to. It's an int. The value contained on the memory address pointing. Okay, is now because I changed it at that pointer. It's pointing at. I pointed at it. I told the pointer to change that box, and now it is no longer it. Pointer arithmetic. Remember that a pointer is a special type of integer variable. This implies that basic arithmetic operations can be done on pointers. This exercise will explore this idea. The only arithmetic operations allowed on for pointers are addition and subtraction. Conceptually, adding to or subtracting from a pointer means the pointer will point to some new address. Multiplication is not allowed because the address of a byte of memory is usually a large number, therefore multiplying an address may yield an even larger number, possibly representing an address outside the bounds of the available memory space. Division is not allowed as it potentially allows a pointer to logically point to an address with a non-integer index. The addition operation for a pointer is only valid when adding an integer to a pointer. You cannot add two or more pointers together. The syntax is traditional addition illustrated by the following example. Just sound that shit. I want to move 4 houses down on my memory, just move it. The important thing to note here is that adding any to a pointer does not increment the address to point to a value n bytes away. It moves the pointer by n times the size of data type in bytes. Naturally. But the size of type that is pointing at. For example, a pointer to an int, the size of which is 4 bytes, usually contains 100 addresses. We will use a decimal address for simplicity, and 3 is added to the pointer will now point to address 112. That is 4 times 3. Let's take a look at how it goes, how it works. So it moved the distance 3 houses down, the int houses, 3 blocks of int. This code increments the pointer PTA to store the address that is 3 int sizes away. Incrementing by 1 can be done in the following way. Increment. Subtracting from a pointer behaves in the same way with the address being decremented instead of incremented. Pointers are that powerful and allow greater control over a program, but with great power comes great responsibility. Working with pointers arithmetic can be dangerous if used carelessly. If an attempt is made to increment or decrement a pointer beyond the bounds of the memory space of a program, a crash will occur. Pointers are so dangerous that many high-level languages such as Java do not even allow such operations. Be careful. Out of bounds exception. Stack overflow. Stack overflow is when you fill your memory so much that the pointer keeps back where it started. Its loop is so big that it's loop upon the entire memory and goes back hell right in the beginnings of the memory. And so it crashes and dies because it has lost what it's meant to go back to. Goes amok. Increment the double pointer PTR by 5. Decrement it by 4. Fucking just so they could put an exercise in this. This thought about nothing about pointers. We did not use to do anything, but better than nothing. Pointers and arrays. In the lesson on arrays, you learn that an array is a contiguous block of memory reserved for many variables of the same type. Because of this structured organization, a pointer is well suited to work with this data type. If we have an integer array, we can use pointers and pointer arithmetic to iterate through the array to access or manipulate its values. This might seem like an overcomplicated way to work with arrays, but there are some advanced applications in which working with an array through a pointer is necessary. Consider an array of integers R. These arrays are contiguous blocks of memory. If we have a pointer to the first element, we can use pointer arithmetics to access the rest of the array. Keep in mind that while this is a valid way to work with arrays, it is unsafe. Accessing memory outside of the bounds of the arrays will not cause a program to crash, but will silently corrupt the data stored in those addresses. In the case of a read operation, it will return a random value. With caution in mind, let's see how we can carefully access and manipulate elements in an array using pointers. The following code prints all of the elements of the array. This is an array. They made a point to the first element, and then they can iterate through it, printing all values. It means incrementing the pointer to point to the next int. Holy shit. Exactly at the bounds. Following code illustrates how to change the values of an array using pointers by changing all the elements in an array to 3. Just link the array to the first place, that's index 0. It's now pointing at that slot of memory. Then you make that fucking slot to be 3. And you iterate through every slot from 0 to 10. At each iteration, you increase your pointers to the next slot and make it 3. Move it to the next slot, increase 3. 10 times until you move the entire array. Now the entire array is 3 on every element, 10 times. The output of the code above will be a string of 10 trees. These techniques are also applicable to strings since they are arrays too. It cannot be stressed enough. Be very careful when working with these pointers. Create a pointer to an int called ptr and have it point to the last element in a array equals at breaking last element. Using pointer arithmetic, loop through R and print the contents in reverse. Bit shit, but okay. For int u equals 9. How is it now? 9 bigger minus fucking 1. I decode this shit and decrement it. And as you do that, I want to print the contents in reverse. Print that thing. What's a character? How do I print a character? Not a character, is an int. And let's see. Create a pointer to a char or pointer to and set it to point to the first character string s. Now it's char pointer to equals s0. Something happens. The invalid conversion from char to char. To point at the location. Using pointer arithmetic on pointer 2, loop through the string s and replace all characters with the character it's called again hashtag. So do this trick again. I have to find the length of that shit. What is the length of it? Length, size length, string length of s plus 1. What I want to do is to put s at you. Equaling the hashtag. And something died. You reference that pointer and use it to change the character in the string. You mean I should reference the pointer and use pointers arithmetic. That's actually what they told me to do. Okay. I do it using pointers arithmetic instead. Instead of this perfectly fine thing, I have to do it like this. Pointer 2 plus value at pointer 2 shall be this. That shit. You look through the string, replace the character with this shit. I think I did. Arithmetic. Just replace the characters. Replace that thing, and this is pointer arithmetic. What does it want me to do exactly? equals this shit. Oh, that's exactly what I did, motherfucker. String language. That's identical to mine. Fun and games. For point to the first element, I have done this before. For int the counter equals 0, the counter value less than the length of this switch. About I put a plus 1? Did I not? Because I should. Well, it worked now. It would work before the same way. Just fuck some memory of mine, but it would work. At worst, would suck some memory. To change the very damn thing, you crash a bit of it in a string, it have no ending. Review. Congratulations on completing this lesson on pointers and memory management. Here is a brief recap of everything you have learned. The base unit of memory is a byte. Memory is represented as a block of bytes. These bytes have an associated address, which is represented by a hexadecimal number. When a program is running, it is the responsibility of the underlying operating system to reserve a block of RAM for the program. A pointer is a special type of integer variable that stores the memory address of a regular variable. A pointer can store the address of any type of variable, including other pointers. The address stored in a pointer is the address of the first byte of memory that stores a variable. A pointer can be declared in two ways: data type asterisk name of pointer, data type space asterisk name of pointer. The asterisk can be on the type or on the pointer. To obtain the address of a variable such as that it may be assigned to a pointer, the reference operator and is used at. Accessing data that is stored in a memory address pointed to by a pointer is done using the deference operator asterisk. Pointer arithmetic is allowed, but only for addition and subtraction by an integer. It is not possible to add or subtract one pointer to from another pointer. Incrementing or decrementing a pointer is done in the following way. Incrementing and decrementing a pointer changes the address by any times the size of type of data the pointer is pointing to. Because an array is stored as a contiguous block of memory, a pointer can be used to traverse it. Great care must be exercised when using a pointer, as it is possible to accidentally corrupt the data stored in other memory addresses. Good luck. Learn how C language handles memory. In this article, we will explore how the C programming language manages memory. This article is divided into the following sections: Introduction, memory maps, variables in memory, memory access, memory allocation, conclusion. Introduction. A key resource for the execution of a program is memory. When a program is running, memory is used to store relevant variables and other data. Memory in a computer is a finite and expensive resource. If a process occupies too much memory, it will lead to poor program performance. Therefore, it is important to be conservative with memory and only use it as little as possible. Programs are created by writing code in programming languages. Each language has its own rules regarding how to work with memory. The C language, being a low-level language, one step above assembly, offers a programmer access to memory with very little restrictions. Other languages such as Java and Python do not allow the programmer to directly interact with memory. This has its advantages and disadvantages, as we will see in the remainder of this article. In a computer, the physical memory is a piece of hardware with complex electrical circuits on it that are used to implement the function of remembering something. This is known as RAM or ROM. If you have ever taken part or put together a computer, you have likely seen these pieces of hardware. They are the memory stick of RAM and your hard disk for room. The programmer, not being a computer engineer, is not concerned with how these pieces of hardware work, as long as they do. To the programmer, the memory is represented as a memory map like so. RAM is represented in this way. It is very likely that you know how much RAM your computer or phone or tablet has. This number is usually coded as some amount of gigabytes. The fundamental unit of memory is a byte. Each byte of memory has its own address and is used to store data. This address is usually enumerated using the hexadecimal number system. The addresses can be seen in the middle column of the table. It is decimal because it's intuitive for beginners. C allows direct access to these addresses. Variables in memory. When writing code, programmers frequently work with variables to store and manipulate data. A variable occupies a contiguous block of bytes in memory with the size of block depending on the data type of the variable. An int variable on a personal computer typically occupies 4 bytes of memory. A floating point variable occupies 80 bytes of memory, which is why it is known as a double. A character occupies 1 byte of memory. The amount of memory occupied by a variable can be found by using the size of function in C. The address of the variable in memory is the address of the first byte occupied. A running program is allocated a section of physical memory by the underlying operating system, if there is one, to store relevant data. Because it's considered a low-level language, C allows to directly interact with this memory through the use of what is called a pointer. A pointer is a special type of integer variable. This stores the memory address of a variable that the pointer is pointing to. To obtain the address of a variable, C provides a special operator called the reference operator. To read or write data to an address stored in a pointer, C provides an operator called the reference operator, which are the fucking same asterisk, but okay. No, the first one I mentioned is that the end, but in order to declare the pointer, you need to use the asterisk the same way. Allowing such unrestricted access requires great care. Errors involving memory access with pointers are sometimes silent, as they don't cause compile time or runtime errors. Erroneous memory access, for example, you access and change the data at the wrong address causes the program to produce incorrect results and may even behave unpredictably. These types of errors are incredibly difficult to find correct. It's insane. There is a reason no one is allowed that anymore. Program memory is organized into two main categories. The stack and the heap. A stack is a section of memory that is highly ordered and data stored on the stack are only available within a certain scope. You'll learn about this in the lesson of functions. In contrast, the heap is not as ordered as a stack. When you create a variable in the usual way, you are statically allocating memory and it is stored on the stack. That memory will be released by the program when the variable is no longer needed. The heap allows you to reserve as much available memory as you want. That memory will remain available until you explicitly release it. This is known as dynamically allocating memory. Forgetting to release the dynamically allocated memory will cause a memory leak, leading to poor program performance. That is, it accumulates trash. It makes those shitty games that have no optimization or performance. C provides 4 special functions for you to dynamically allocate and release the memory, provided it is available. They are malloc, calloc, alloc, free. Realloc, calloc. These functions are stored in the stdlib library. To use them, you must import this library. You will need a pointer to work with the memory provided by any of these. Malloc. Use this function to reserve as many bytes as you want on the Use this function to reserve memory for some number of int doubles or any other data type. Use this function to expand or contract a block of reserved memory, reserved by either malloc or alloc. Use this function to release previous allocated memory. The most important of this function is free. It is necessary to release memory that is no longer needed to maintain efficient program performance. C is one of the most powerful and versatile languages available. Because of its memory management style, it is used to create programs for many industries. However, when working with memory in C, it is imperative to be careful. Memory is one of the most precious resources a programmer needs. Therefore, it should be used conservatively. Errors resulting from incorrect memory access or leaks are detrimental to the operation of a program and are difficult to find and correct. As the age-old saying goes, with great power comes great responsibilities. Be careful when directly working with memory in C. Freaking functions. Let us dive into the heat. As you continue to write more code, there will be times when you need to reuse a set of instructions. You might be tempted to reuse the code by copying and pasting it, but in times like this, a function is a great tool to use. A function is a group of instructions that is given a name to be used elsewhere in the code, often repeatedly. Functions can take in a set of inputs and produce some output. In the photo above, we use the idea of a function to make cookies. We collect a set of instructions, the recipe, under the name make cookie. Baking a cookie requires a set of inputs, the ingredients. The instructions inside the function act on the input ingredients to produce the output. Functions are great because you can write, don't repeat yourself code. You can execute any number of instructions with a single line of code. Once a function exists, you only need to worry about the inputs and outputs and not about the instructions inside. In C, you have already worked with one function. The main function is the entry point of any C program, and you will understand it better as you go through this lesson. And the print to the thing function and every other thing I call in parentheses. Look at the main function in the script C file. There are two lines, one that calls a function abs and the printf function to output the value of absolute value. Run the program to see the output and think about all the things happening in the code that we can't see. This is a good example of don't repeat yourself coding in the C programming language. Gives the absolute value of 5 is 5. Calling a function. As you have seen the code, printf reload word outputs the string between the parentheses, the console. The general usage of a function is to call the given name with a set of parentheses. Any input that is needed for the function is placed inside the parentheses. These inputs are commonly known as the arguments of the function. Certain functions take no arguments, some take one and some take multiple. No matter the case, it is important to know what arguments a function expects, so we use the correct values in the correct spots. The printf function can change its behavior based on the number of arguments it receives. Outputs reload. Outputs my number is 9. As the arguments of the variables it contains. In the example above, the first printf call takes the string reload word as an argument. It outputs the string. The second printf call takes two arguments, a string and a variable. The output this time is the string with the variable inserted where indicated by %d, modulo d. These two uses of printf show the flexibility that is allowed when using functions. Lastly, a function can return its output, which can then be used further. For example, what did it just say? A function can return its output, which can then be used further. Return this output of 5, transforms the 5 into its absolute value. In the example above, we use a different function, absolute, which returns the absolute value of an integer passed as an argument. We are able to use this function by adding the line include this library to the top of the code. As we can see, when we call absolute 5, we are assigning it to the integer absolute value. This assigns the value returned by the absolute to the variable absolute value. This is shown by outputting the value, which is 5. Let's take a look at the different function argument configuration of printf. In script C, add a call to printf with no arguments. You should get an error when you call printf with no arguments. I should. Now add a string of your choice to the argument. Does it work now? We now add the value of number 1 to the output. But be sure to add the variable as an argument and adjust your string to support the variable output. When you add another variable output, give it a try. As a third argument, add use this string library functions. Now that we know how to call functions, use the argument and capture the return values. Let's take a look at some functions provided by the C programming language. C gives us access to many useful libraries that include many different functions for you to use. In order to have access to these functions, you need to include headers, files like Studio and std. You have already used printf to output text to the console and learn about absolute to find the absolute value of an integer. Here are a few more functions we might use in your program. Cell takes any number as an argument, round it up to the nearest integer, and return the integer. Log takes an integer as an argument and return the natural logarithm of the given number. Super takes a character as an argument and returns the uppercase of any alphabetic character. Is upper takes a character as an argument and returns 1 if the character is in an uppercase letter, 0 otherwise. 1 or 0? Not a boolean? The fuck? Let's use these functions in some codes. In the above example, the math and C-type libraries are used in this code. The number variable is passed to cell and outputs the result 5. The number variable is passed to log and outputs the result 1.5. The letter variable is passed to is upper and output the result is 0, which represents false. The letter variable is passed to tuple to assign to the letter. The assign to letter. The new value of letters variable is passed to is upper and output. The result is 1, which represents true. There are many useful functions contained in the C standard library. Here's a list of some of them. It is worth looking through them to see how they can help your code. Now let's look at some more libraries and their functions to create some random numbers. In the script C, there are 3 include statements. The first is needed to print f. Include this library is needed for 2 random numbers generator functions, surand and rand. Time ag is needed to use the time function. Inside the main function is the line is rand time new. Without this line of code, every random number generated in this exercise will be the same number each time you run the code. Look a hint for more details on this line of code. Move to the next exercise to continue with the random number code. It is taking my current time and using it as a seed to generate the random, right? There's a random function to set the seed for the random number generator, yeah. The seed initializes the random generator and should be a number that changes over time. The time function used has the rand argument to ensure that the seed is a different number every time the code is run. When passed the argument null, the time function will return the number of seconds passed since the date January the 1st of 1970. With the random number generator initialized, it is time to get a random number. This is done by saving the return value of the function rand inside the main function. Declare an integer int random number and set it equal to rand. Output the value of random number using printf. If you run the code multiple times, you should get a large but somewhat different number each time. Printf random number There's a good chance if you were programming a game that wanted to roll some dice, the number being generated right now would not be helpful in its current form. To get the number we want, we will use the modulus operator. Using modulus, change the line of code into random number rand so that the random number will be between 0 and 90. Add a +1 to the end of the code, so random number becomes a number between 1 and 20. Every time you run the code, you should now get a number between 1 and 20. Random number to 20, 0 to 19, plus 1. To the end of the code, it works, but that's not what they want me to do. See, it's between 20, 1 and 20. But they want me to write it down here. I have no idea what they are saying, man. Motherfuckers don't know how to write some instructions sometimes. What do they want me to do, motherfucker? Tomar no meio do cu. That's that the fucking hell I just did. Why are you retarded again? Random variable? What the fuck is a random variable? There's no random variable mentioned. Am I a joke to you? He wants me to use it without the implicit order? Now it works. The fuck. Defining functions. We have seen how C comes with many handy libraries full of functions for us to use. Now let's learn how to make our own. To begin, we need a function signature. The function signature tells us three things: the function name, how many parameters, inputs, the types, what type of return value is to be expected. Return type, function name, type 1, parameter 1, type 2, parameter 2. That function I tried to declare did not work because I tried the type string. It does not exist here. That's the problem. If a function isn't going to return any type, void is used as the return type. Void indicates to the compiler that the function returns no data and should not expect to see the return keyword. Any of the types covered in the previous lessons can be used as the return type of a function. Similarly, if a function has no parameters, void should be in place of any parameter. The parameters listed inside the parentheses are like variables declarations. Each parameter should start with the type and the name of the parameter. The code statement inside the function are known as the body of the function and are enclosed with curly braces after the function signature. The signature and the body are the two parts we need to create. We need to create our own functions. Time to create your first function. It is not okay. Above the main function, insanity. I'm not going to put right above the main function. Define a new function. As no return value is void print my favorite animal. The function returns no value. The function has no parameters. Leave the body of the function empty for now. Inside the body of the function, output the message. My favorite name animal is your animal name. This completes the function. So move on to call your first complete function. My favorite animal is monkey. Lastly, design the main thing call. Print my favorite animal. Broke. Seven. Print my favorite animal. Implicit declaration. I do not declare it. So I have to put the shit. It's my favorite animal. It gave me all okay over there. I need to put it above. It reads it in order. Otherwise, it will not see the function as declared. What the fuck? Function return values. We now know how to define a function, so let's look closer at function return values. Calling a function to do some work and return a value is a common use of functions. It is important to understand how to define what type of value is returned and to ensure that it is returned. Many of the C types we have seen so far can be used as a function return type, like int, double char, and even pointers. Crazy shit to return a pointer as a function. In the example above, the function was return type int. The variable secret number of type int is set to 7. The variable is returned using return secret number. The type of the value returned inside the function must match the type defined in the function signature. If there is a mismatch, you will get a compilation error telling you of the mismatch. Once the return statement is executed, the function gives control back to the function that called it. No further code within the function will be executed. For example, the printf statement will not execute, and don't tell anyone will not be displayed in the output terminal. Just jump out, it ends the function. Continuing with random number generation, modify a function that definition so it can return a random number from 1 to 1000. The function getRandom 1000 printed as a return type of a void. Change the return type of the function, return an integer. So it's in void here. You have to make it an integer. A very weird shit is that the main is an integer. Full insanity. And I have to return. Lastly, in the main function, replace the 0 with a call. And the store to return a value, the verb. Yeah. Get random 1000. And I can run random numbers. Shoo-doo-doo. In the last exercise, we created a function random 1000 and returned a random number between 1 and 1000. But we wanted upper bound to be 1000 or a million. We could define new function get random 10,000 or get random a million. There must be a better way. Besides returning value, functions can customize the behavior based on the argument passed to them. This is done by defining parameters in the function's signature. Parameters are variables definitions that take place in between the parentheses of the function's signature. They have a type and are given a name to be used inside and only inside the function body. Let's take a look. The example above the add_to function is defined with an integer return type. The function takes two integer parameters, number 1 and number 2, to be used inside the function body. The function adds the numbers together, assigns them to an integer, sum, and returns sum. One thing to keep in mind is if the parameter type and the argument passed to a function do not match, a warning on an error will occur when we run the code. These strong typed languages are divine. The language is just passed a random number, a random name, like it was, I don't know what the fuck, a hell to debug later when the type is mismatched. You have no fucking idea because there are no types on that shit. You just put some random variable name without any type. So C is very nice. The code above you produce a warning that the sayIt function argument type char and the parameter type int are not the same. This will result in wanted behavior. The last thing to note about parameters is if a function does not have any parameters, you should put a void in between the parentheses. Leaving them empty will usually be okay, but it is best practice to use void. That's weird as shit, but okay. The getRandom function has been changed to getRandom number. Modify the remaining part of the function definition. Add an integer parameter. Int max number. Inside the getRandom body, use the parameter to set the range. Max number. Now test the new function out. Well, you call it here. Assign a random number to get a random number generator. Get a random number. 100. 100. Any number I want. Functions with pointers. We have made great progress so far with functions. Up to this point, when a function has received an argument, the function makes a copy of the argument's value and stores it in the parameters variable. Now, any work that the function does on that parameter variable will not affect the original value passed in. For example, I have a main. I have the variable a. I want to pass that variable for the function. I want it to sum it with 2. Then say that is 12. And you have that value of 12. But here the original thing is still 10. Does not change. But with pointers, it behaves like an object where it changes the value if you alter it, if you make arithmetic with it, if you do anything to it, change any property of it. It's great because you can safely alter the variable value inside the function while maintaining the original value outside. What if you want to alter the variable inside the function? Instead of passing the actual variable as an argument, you can pass a pointer to the variable. Remember, pointer is a variable that holds the memory address to another variable. The memory address tells you where the original variable is in memory. When we pass a pointer to a function, we need to make sure the parameter type matches the type of pointer we are passing. If the pointer has a parameter, the body of the function can directly alter the original value of the pointer that was passed. Then I make a pointer to a, I pass it as a pointer because the function actually takes a pointer. I take the pointer, I change the pointer, now a and the pointer are equal. They point them to the same place in memory which was altered. A benefit of using pointers to a variable as opposed to the variable itself is that it saves memory, as the function does not need to allocate more memory for complex data types like arrays or freaking objects. Let's look at how we can change values in functions using pointers. Above the main function, define a function named increment. Increment age that returns no value, so it is void. The function should have one parameter, an integer of a pointer called age pointer. The body of the function should increment the value that age pointer points to. So age pointer written increment. Did you increase the value pointed age pointer? Age pointer. Pointed by age pointer. Age pointer. What am I doing wrong now exactly? Increment the value that age pointer points to. And choose the retrograde, which is this piece of shit here. That's about it. Void does not need to return anything. I'm taking age pointer, define a function. There is one parameter. I do not need to declare this age pointer shit. The parameter. The body of the function will increment this fucking shit. Thus, now what? Edit wants me to do. Ah, vai tomar no meio do cu. Why? 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 That makes no sense. Why does mine work not? Age. I have to repeat this piece of thing because the thing wants me to. Because it would work before. Let's use the shorthand. Inside the main function, define an int age. Put my age, I'm 25 already. Time. Deve ser foda. Increment age should be called. I should pass my age. I should output this. Crashed on the 11th. Increment age. It passed the age, but it crashed because it has to be a pointer. It needs the at. I'm 26 now. It made me even older. I'm dying faster. Function prototypes. So far, when we have called a function, we had to make sure that it is declared above the line of code from where we are calling. If not, the compiler will have not stored the function signature to check if the function call is correct in terms of return and parameter types. Instead of making sure our functions are always declared above when they are called, a good practice is to define function prototypes at the top of our code. That's something very silly, some delegate shit, but okay. Function prototypes. The above example shows two functions prototypes toward the top of the code. The main functions call upper functions, which then calls lower functions. Upper function knows about the lower functions due to the function prototype at the top of the code. The compiler is made aware of each function's signature before the entire body of the function is implemented. One thing to note is that the names of the parameters associated with the functions are not necessary for a function prototype. The compiler is concerned with three things when it comes to function prototypes: the function name, the return type, and the parameter types. Function prototypes are a good practice in C, and they help you expand your code without any unforeseen errors, due to the compiler not knowing a function's signature. Currently, the script C gets a warning, as it is, since there are functions being called before they were declared in the program. Just under the include, create a function prototype for repeat. This void repeat digit, and it takes an inch. Get random number. It returns an int and it takes an int. Now it works. Summary. Great job learning about functions. We have managed to cover many important topics, like functions are a named set of instructions. Functions can take in a set of inputs and produce some outputs. Functions help you write, don't repeat yourself code. C comes with many libraries that contain useful, ready-to-use functions. Functions calls can take arguments and return values. Functions are made up of function's signature and body. Void can be used as a return or parameter type. A function returns a value with a return statement in the body. A function can have parameters that are placeholders variables for the function. Pointers can be used as functions parameters to help with memory management. Functions prototypes are good practice in C. With the help of functions, you can now build bigger, clearer projects. They do not stress nearly enough that functions are the entire fucking code. You do not write things in the main. You do not do that. Because just as you call this thing, not using functions would be like rebuilding the entire hardware, rebuilding the entire code every time you want to do anything. It's obviously impossible. And a piece of code here. Where is it? This one. No, it's not showing the screen. I've navigated to this. Yeah, create this shit. Here, my primer is my actual code. My actual thing, it's a little different from that one, but it starts here on the main with a bigger M. And then I simply call the function and it starts shit. This portal loads a character. What is loading? Or it goes somewhere after loading it. But it can also create a character. And when creating a character, it calls this the persona. This is a function that calls all the other functions that build the character. As you can see, it's impossible to write that over there. And sometimes you need to just call the roll of a dice. Like in Mechanic Eye, I have the calculate function. Here it asks the console what the player wants, and it calls several functions. It would be impossible to write all these things here. Unpractical. Call the roll of the dice. And down there you can find the infinity of functions. So functions are everything. You won't be writing functions and then calling them from afar. They are where all your code is organized. When I studied programming for the first time, it was very confusing. Why would I use functions when everything could be done here on the body of this? But as you can see, codes will soon get to thousands of pages, and it's absolutely unmanageable on the main. You do not even use the main anymore. You just call your main loop on there. Go on writing hundreds of functions for everything, calling them back all around on this interconnected network, not this linear progression. Learn what the scope is, the different ways of defining scope and how a program uses scope. When we write the programs in C, we define many different names for variables, functions, and other identifiers. We may find that all access to these names components is unavailable in certain parts of a program. Is there a way for us to know when certain names are available? As it turns out, the scope of the name tells us exactly this. What is the scope? The scope refers to the part of the program where the name has a meaning. For example, some function. In the example above, my variable, some functions, refers to an int variable whose value is 20. My variable's name in main refers to a char variable whose value is 10. Both these variables have the same name but different meanings depending on the scope. We have actually already done a lot of scoping throughout these scopes. In C, the scopes are defined within curly braces and therefore can be created using constructs like if statements and functions. So this variable only exists here, inside this place, this one here. And if there was one out there, it worked for all of them because it's in the entire class. Although there's no class here. And if you want to use a variable from this script on another one, you have to import. That is what those upper libraries are. We're importing a shit ton of variables and functions from other scripts. This works inside and outside here, but not out here. And C only works inside of here. There are two scopes in the above example. A scope within the my function defined with the outer braces, a scope within the if statement curly braces, all inside the my function scope. If A braces encloses the meaning of C within it and make it unknown outside of if block. The if braces do that. The my function braces enclose the meaning of B within it and make it unknown outside of the function. Given the function code block, how many different local scopes have been defined within my function 2? As you can see, my function 2 itself is a scope, and this works on its entirety. It works here, the scope of this thing. And there is a B, that is works here and here. And there is another one. There's another one. We have this main scope. The deeper level we have is this third level. We have 4 total scopes. This. Local scope. Let's look at another example. This and this. Print the value of B. It tries to do so, but it's impossible because it's trying to access something outside. It only exists here. The above example defines the name A known only to main and B known only to this. The local scopes means that B can only be accessed with the function body of my function. Outside of my function, B cannot be accessed. In other words, B is not known to the other scopes, therefore they don't have it declared. The only way to make this print statement exist is by accessing this function. You can have this silly thing outside here so that everyone can access it, or you have to call this. So you have to call my function and pass some variable and have a return type to that function. And has it return B, you equal B to something else and use it. You have to do that. You have to call the function and access it for B, or you have to declare it outside. Those are your options. If my function was only meant to have B, no, return B, which it does not because it's void. The local scope means that, that if we try to run this program, we would get a compilation error, B undeclared. This is because the name B is not defined in the main function local scope. Similar situation occur when you use other constructs like if state. So we make an if that has a B inside, try to print the B outside, which is the same thing. In the example above, the following would occur. The name C is defined locally within the body of main, and is unknown outside of the function. C is part of the main scope. B is defined locally within the body of the if statement and is unknown outside of the if block. B is part of the if block scope. B may appear as if it's part of the main scope, but it's really the if scope that is defined inside the main scope. We would get another compilation error here because we are trying to access the name B in the main scope when it's only defined in the if scope. We can also make it public. What is there of that in C? Static and all kind of shit in order to make things available elsewhere. Given the following code block, how many names are locally available in my function, and main scopes? How many names are locally available in my function? I have A and B available. C and these are the C as only available inside each of them. Main has all these things that have nothing to do with my function. My function has 2, and B has 3. This one is outside his jurisdiction. My function has 2, and B has 3. B has 3. Global scope. Now that you have covered local scope, you can take things global. In C, there exists a top-level scope called the global scope. The global scope contains declared names, but access to those names work differently than the local scope. Let's look at an example. I have a global scope here, just declared outside. There is no global variable. Some languages use the global word and that kind of thing, but they just declare outside. So everything is in the scope because it's part of the supposed class of the script. The scope of the script. In the example, the name B is defined globally. Global name is defined outside of functions, including main. A global name is available to access and modify everywhere in the program, including inside functions. Although global names can be useful, they should be avoided because as our program grows, it will be harder to track where a global variable is being read or modified. This makes things harder to test and debug. With a larger enough program, we might run into naming conflicts between global variables. As a general rule, functions shouldn't modify. A minute here, I just saw some weird shit passing before my eyes. With a large enough problem, we might run into naming conflicts between global variables. As a general rule, functions shouldn't modify the state of variables outside of its local scope. This keeps function logic isolated from each other and keeps your code reusable and modular. Parent and child scoping. So far, we have established that a name defined inside an if scope cannot be accessed outside the scope. We have also been able to access a name defined in a function scope like main inside an if scope. This is possible because of the relationship between scopes. Let's look at this example. We know that f is a global name and it's available everywhere in the program, and that a is local to main and b is local to the if block. How does C know to look at the global scope for f and main, the scope for a? This is the parent and child relationship of scopes. The global scope is the parent of main scope. It contains the main scope. Alternatively, we can say that main is the child of the global scope because it's defined within the global scope. The main scope is the parent of the if scope, making the if scope the child of the main. The compiler takes the following steps to find the definition of f and a. The compiler tries to look for the definition of f and a locally in the if block. If the if or a or both can be found, it checks the parent scope of the if block, the main scope in this area. If f or a or both can't be found, it checks the parent scope of main, the global scope in this case, the script. These steps continue repeatedly until all the names are found or there are no parent scopes left to check. At this point, compilation error would occur. In this example, we stop looking for a at the main scope because it's defined there, and we stop looking for f at the global scope because f is defined there. Great job learning about scope. Learn what scope is, different types of scope, local and global, parent and child relationship between scopes. Try and complete the code challenge to test your understanding. Completing main to print the following message. If my number variable local to main is less than or equal to 50, the output will be 39. This is my global message. If the my number variable local to main is greater than 50, the output will be 500. This is my local message. You want me to do what? Complete the main? You can change my number to be larger than 50. Message. This is my global message. This is my local message. Print this message. I can change this number at will. At this one, this is my global message. I have to call the global if it's lower. So I just print. message. And it's calling this into my number here. Why is that? Okay, I have to run it like that, and this one I have to call the thing, which is fun. This is my global message. Not display my number though. I should say my number. Here too. I can change it to 51 to be 500. The extractions. There is still extraction on this thing. When we end, I have to sleep. It's 5 in the morning. It's already clear outside. Holy shit, I spent all the night here. Oh my gosh. I'm hungry as fuck. I'm kind of sleeping, non-sleep like a zombie. And I still have to study Greek before I go to sleep. What day is it today? Let's finish this thing. Extraction lesson. Introduction. Throughout this course, we have defined many different variable types like int and char. These are known as the basic types and are built into C. We have also defined data types like arrays and pointers, which are known as derived types. Derived types tend to be a collection of basic types to create a new, more powerful data structure. We will now explore another derived type, the exstructure. The superstructure. The freaking object. In C, structures allow programmers to create user-defined data types. Structures like arrays allow you to collect many data types into one single data type. But unlike arrays, structures can be a collection of multiple data types. Like this. The above image represents a structure and the different types of variables contained within it. This type of packaging is beneficial because it helps build and pass around logically related data in a single user-defined data type. Take a look at and run the code in the workshop. Notice in the script.c file all the variables that are defined. Think about how you could use a structure to organize data. My name is Ada Lovelace. I'm 20 years old and I'm a mathematician. This is not using the structure. Could make it. Why is this? Oh, because it's a string. String says a race. If I pause there for a moment. Why is this array? Defining a structure. To help us understand how to include structures, also called extracts, in our code, let's look at how to define them. This will be defined on a different script, but okay. Can I make a new script? Huh? So I put the keywords and structure name. That's it. Happy thoughts and prayers. In the image above, extract keyword imitates the structure type definition. Bottle is the name of the new structure type. A set of curly braces to enclose the structure member variables. Inside the braces, the member variables are packaged together. Member variables can be any basic types, int, character, etc. They can also be derived types like array pointers and even other structures. It's important to note that the member variables should only be declared and not initialized. We'll learn about this later. Attempt to give the member variable values will lead to an error. Time to define your own structure. Within the main function, declare a structure named person. The part of the structure name. Something failed me. It's a closing thing. Inside the person structure, define a string. There's an array of sharp called first name. And int called age. Build again. There's a writer. Define a string member variable. First name with a length of 25. Oh well, what the fuck is happening now? First. Yes, motherfucker. I forgot to close this thing. Oh my god. Initializing structures. Now that we know how to define structures, let's take a look at how we can use them in our code. The above example defines the struct bottle from the last exercise. The last line of the code then initializes a struct using an order notation. Extract keyword once again. The user defined the extract type, bottle. The name of the structure variable, bottle1. The member variable value assigned with a set of curly braces. The order of values assigned to the member variables match the order in which the variables were defined in the structure. If you wish to be more specific with your initialization and not worry about putting elements in the right order, you can do it using an unordered notation. Specifying the name. Once initialized, structures allow you to work with complex data types in a more cohesive and efficient manner. Before you initialize your first structure, expand the person structure. Inside the person definition and right after the first name definition, add a last name definition. String member variable with a length of 40. Char last name 40. Initiate a person. Struct person1 with the data below. Is other Lovelace. Be sure to place the data in the same order. Has an equal sign. It's very primitive when compared to an actual object. It also has functions and all kinds of shit on it. Instantiate another person using a person structure. That the main function initiates the person struct person 2 with the data below. Shall to place it. Query. Why use X structures? Let's now take a step back and discuss why we would want to use X structure. Look at an example of a program that uses bottle data without X structure. Bottle name, max capacity, current capacity, bottle name 2, max capacity 2, current capacity 2. Notice that we need to keep track of 6 variables while working with this bottle data. As we increase the number of bottles, the number of variables will increase by 3 per bottle. This approach can get extremely unmaintainable. In a small number of situations, we could possibly use arrays, but that's only when the data is the same type. But this is useful all the time. Using a structure and encapsulate all the members that represent a bottle, we can reduce complexity by representing a set of data with one variable, package different but logically similar data together, better represent real-world things into data types. Being able to represent data using structures is extremely beneficial as you continue working on a more complex real-world problems. Someone has been working with a group of variables that represent cough table data. Use structures to organize this data. As you can see, this is awful. And structures are really good. Not objects, but not as subject, but much better than the variable flawed things. Create a table structure. Extract table. Define the following variables inside. It's all int, the same as that. Table. Int length, int width, int height. And char color 20. Now initialize the data utilizing defined structures. Table 1 and table 2. Extract table 1 equals 24, 20 dark brown. And I can quickly generate. Keep it very well organized. Whenever I need the name of anything, or when I need to check this data, I can take the table, just consult everything it has, instead of random separable variables. Something went wrong. Double check the syntax. Tablet. Now it works. Structure, not dot notation. Now that we have leveraged that power of structure to package variables together, we can discuss how we can access each member variable individually using dot notation. Dot notation is to call them individually, but on the question of the power of structure, I want to open this thing again. Where was it? Did not save here. No. This persona is an actual object. This primo here, it's loading a character. And a character naturally the collection of objects. How do I collapse this shit, man? I always forget. I probably have it written over here. How to collapse this shit. Control number to collapse layers. Control G, Control K. These are the variables a character has. So it has a name, it has a surname, it has a gender, it has life points, it has mana points, it has money, it have complex objects of its mana, its spells, its abilities, its professions, masteries, its dexterity, strength, intelligence, wisdom, its health, its like the endurance it has, its height. So it needs many things, but you can generate it extremely easy by having this kind of thing. You see, I'm generating a band here. I put the name bandit, I put the ability it needs to have, what it is drop, which would be completely unmanageable without these things. I'm generate weapons here. Come here, the weapon. It's a weapon has a name and has the damage types, the price, and here I generate them. Here is the generator. It's much more sophisticated for objects than for a structure. It's a function and has several things that it takes. When it comes here, I generate them. I make a weapon, a new weapon. I put the name, I put the material, I put the type, I put the damages, the price, the things, and the skills. And so instead of possible variables, I can create new things and populate it real fast. If I'm making accounts for a bank, it needs to use this. Populate real fast, making new things as inherits or characteristics from this model object. Here I have some drops like iron or copper or like very easy to generate a new item with several characteristics by inheriting those things. So this is the power of those like, structure or rather of objects and why it's so important to learn to use functions and it properly. Because you cannot make anything without that. Now, this dot notation reference exactly to the thing you want instead of putting in order. So here, not have leverage the power of construct. Dot notation is a C operator that allows you to access and modify a member variable of a structure. Like this. You can just modify that part you want exactly. Or on the declaration of course. In the example above, a bottleneck structure is defined and initialized here. The member variable current capacity is changed, is accessed and set to 10. Of 10. On those other objects, you can also block access if you want to read only and all of that. Set conditions that you cannot go above, not below some number. I have some logic run at that. Yeah. The same variable is accessed again using the dot operator and output with parentheses. Just get that information out as you. You can also use the dot operator to initialize a structure if you would like to declare it first without initializing it right away. So you can just say that a bottle exists and do not define name and quality. And later you can put that in as you feel like it. The dot operator is essential in enhancing the packaging benefits of extracts by allowing you to access any of the bottle member variables through the variable by bottle. The workspace has defined a person extract. Inside the main function, person1 and person2 are initialized as persons. Yeah. And the names of each have also been set. Following the initialization in use dot notation, set the age of person1 to 40 to 54, 57, and the age of person2 to 27. So I will put here person1 dot age. That's simple. Person2 dot age 27. It's access this extractor of age from these two extractor objects here. Extractor pointers. Similar to other derived types like arrays and strings, structures can use a lot of memory. Imagine a structure with multiple strings, each able to hold hundreds of characters. One way to manage memory while working on data types of this size is to use pointers. As a reminder, a pointer is a variable that holds the memory address to another variable. There on C#, that will show the script, the objects that are passed in to another function go with a pointer. It points to the same place, does not copy, because as it says here, it does not pollute things extremely. They are by nature like that, and to a variable be like that, here use a pointer. On there you can specify that you are passing for it on the same memory slot, but you do not use the pointers there. We just use a keyword to signify that. Now here you do use pointers. For structure, this is accomplished by first defining the structure variable, then define a pointer and assign it the address to the structure variable. In the above example, bottle pointer holds the memory address pointing to my bottle. To access member variables with bottle pointer and the dot operator, we can use the following syntax. When using pointers, we need to difference the address to access the variable it points to. When we use the dot operator with the structure pointers, we also need to wrap the difference in parentheses. If we simply difference like pointers name, it will result in an error. Arrow notation can also be used with pointers to a structure, as it implicitly does the differencing for you. Oh, arrow notation, some weird shit, they still use it a lot today to make functions. Just define functions that are out of nowhere without the usual declaration. Notice how much better the arrow notation reads compared to dot notation. This notation is a clear and simple way to work with user-defined structure points. The workspace has two person data types, named person1 and person2. The main function, create a pointer to person1 called person1 pointer. Create another pointer that points to person2 called person2 pointer. Okay then. What's that pointer? I have to create a person pointer. Or random pointer. How do I create a pointer again, motherfucker? Structure name, pointer variable. What a piece of shit. I have to declare the entire thing. I have to call it a person pointer. And now make some changes to person 1. After the point definition and using deferencing and dot notation. After the deference, this actually looks better because I'm used to using dots everywhere to reference to many layers of things and objects. Now change the order structure date using arrow notation. Add 10. Structure in functions. Let's wrap up by using structures with functions. We can specify structures and pointers to structures as parameters to functions. But my function structure. When passing a structure to a function, a copy of the structure is made, so memory usage is a concern. Any modification made to the structure will not affect the original structure, only the copy. When passing a pointer to a structure, because the pointer is the address of the original structure, any modification in the memory variable will affect the original structure. In the above example, bottle function here has two parameters, this structure and this structure pointer. A bottle structure and a pointer to a bottle structure. That the function, the structure are accessed the same as they would whether it is a structure or pointer to a structure. The first argument in the call to bottle function inside main is b1. A copy of this structure is made with the bottle function, and no changes can be made to the values of b1 in main. The second argument in the call to bottle function is b2, the address of b2. Any change to the member variable using this address will change the value of b2 in main. We can also return structures by setting the return type in the function signature. Notice that the structure has parentheses, parameters, and has the return type must use the structure key. Time to look at different ways we can work with structures within functions. In script.c, define the function age1. Give the function a return type of person. The body can be empty. So our structure is the return type. Person age1. The body can be empty. Remember they use the keywords throughout this definition. Add some parameters to age1 function definition. The first function parameter should be called rand1. This is a person. Takes a person and be the type of person. The second parameter should be called friend pointer to and be a pointer to type person. Unknown type, I have to put the extract. Holy shit, it's so painful. I do not know that person is that shit. Now modify the age member variables within the structure. Add 1 to the age variable of friend 1. Using the arrow format to the reference, add 1 to the age variable in the structure point, the 3 and 2 point. Return the structure friend 1 I put it equal to 1. Now test it all out. There are two structures defined in main to work with the function created. Inside the main function, call age1 and assign age1 to my friend. Age1. Set the first argument of age1 to my friend, and the second to my other friend. Run the code and see how it changes. It crashes. Double check your syntax. My friend equals age1 passing self. My other friend 20. Error. Incodable type of argument 2 of age1 extract pass. I have to pass this. Okay, pass it. So it alters then. This one is being altered because it's being returned. This one's being altered because it's been changed on the very memory it uses. This is making a copy of friend one in order to use it. So it's much more resource intensive. This is using the same memory. Summary. Great job learning about X structures. We have covered many important topics. X structures allow you to create user-defined data types. X structures can package together other data types into one type. You can define a structure using the struct keyword. When defining a structure, the member variables are declared but not instantiated. X structures help programs work with complex data and can represent real-world objects. You can access member variables with the dot operator. You can have a pointer to a structure and access its member variables using the arrow operator. You can pass X structures and X structure pointers to functions. You can return X structure from functions. Can I make a function inside a structure? Apparently not. No inheritance, no polymorphism. But that's from higher languages. Without understanding of structures, we cannot create and work with complicated data types easily and efficiently. Use the code in the workspace to play around with X structures. What can you add to the person X structure? What are some functions that would help act on X structure? I could add an int of intelligence. I could add a double of life points, and I could add a shard of face with 10, and then I could call Martin 25 with 10 int and 250 life points and of the race of the elves. For Michelle 25 and 5 intelligence. Raise life points on the race of the orc. Please complete your tasks. There is only one lesson, there's no pro to tempt me to anything here. And that's it. 100%. A few lessons. Beginner level, beginner friendly. It skims over the many topics, does not go in depth in many of them. It is not complete because there is the premium quizzes things. But this was it for the Lance course on Codecademy. Very interesting, can very easily get you started. It even tells you to download the Visual Code, the VS Code, Visual Studio, and where to get the compiler and shit. And so you can just go on and learn very easily with this interactive course. It's very, very good.